डॉक्टर
हेलो
नील क्या?
सर, हेलो, नमस्कार सर। वेरी गुड मॉर्निंग ऑल ऑफ यू।
गुड
हेलो
मॉर्निंग।
अनिल, अनिल सर।
गुड मॉर्निंग सुंदर सिंह।
वेरी गुड मॉर्निंग सर। सर वो आप भेजने कह रहे थे पीपीटी, व्हाट्स अबाउट दैट?
ना बहुत खुश शेयर करेंगे उसे।
ओके सर, थैंक यू सर।
डॉक्टर सिंह क्या हमारे चीफ पैटर्न जुड़ चुके हैं हमारे से?
1 मिनट सर।
वेरी गुड मॉर्निंग सर।
अभी नहीं जुड़े सर।
डॉक्टर राजेश प्रकाश वो जुड़ चुके हैं। राजीव कोठीवाल जी जुड़ गए?
राजीव कोठीवाल जी को देखता हूँ।
और ये प्रोफेसर अमूल्य नागर ये जुड़ गए हमारे से।
नहीं, ये थोड़ा लेट जुड़ेंगे।
प्रकाश जी,
प्रकाश जी भी अभी नहीं जुड़े। अभी सर 10:30 तक जुड़ जाएंगे लोग।
अच्छा ओके।
हाँ, अभी 5 मिनट वेट करते हैं। अरे अमित चौहान जी। अवनीश चौहान जी। हाँ राकेश।
डॉक्टर सुंदर सिंह हाउ आर यू?
आई एम फाइन सर। वेरी गुड मॉर्निंग सर।
गुड मॉर्निंग। कौन कौन लोग डॉक्टर सिंह जुड़ चुके हैं हमारे साथ?
सर 76
अवनीश चौहान जी।
76 participant has been connected.
Okay. And what about our chief pattern and
अवनीश चौहान
pattern?
जी।
डॉक्टर सिंह, हमारे जो आज के जो चीफ गेस्ट हैं वो जुड़ चुके हैं या नहीं अभी? हेलो।
हेलो अनिल सर, हेलो अनिल सर, आर यू गेटिंग मी?
डॉक्टर सिंह, जो हमारा चीफ पैटर्न है वो जुड़ गए हमसे या अभी नहीं? डॉक्टर अनिल, क्या
हेलो।
लेटेस्ट है?
हेलो हेलो।
हाँ सर।
लेटेस्ट क्या पोजीशन है बताइए।
हेलो मैं
लेटेस्ट में बस शुरू करने वाले हैं।
जो हमारे गेस्ट हैं वो लोग हमसे जुड़े या नहीं, मुझे बता दीजिए कौन कौन लोग जुड़ चुके हैं ताकि मैं एड्रेस में उनको शामिल करूं। जो लोग
हाँ
नहीं
वो मैं
जुड़े हैं
चेक कर
उनको वेलकम एड्रेस में शामिल नहीं करूंगा।
हाँ हाँ वो मैं चेक कर रहा हूँ।
हाँ, ओके।
मैं स्टार्ट। हेलो।
अरे राकेश जी,
यस यस बताइए।
actual organizing is refusing for Saraswati Bandana. He is saying that he is unable to
ओके
start that.
यस देन वी विल स्टार्ट विद this program welcome address by Professor Dr. B.V. Singh.
Yes. Okay. Wait for.
Yes.
डॉक्टर अनिल,
हाँ यस सर।
कैन यू हियर मी?
यस।
हाँ, प्लीज एंश्योर अबाउट आवर गेस्ट्स मिस्टर
Okay.
राजीव टिवाल, देन डॉक्टर अमित भारद्वाज, डॉक्टर राजेश प्रकाश, प्रोफेसर अमूल्य के नागर, प्रकाश चौहान एंड मिस्टर परवीन एस मोरे।
Okay, I am watching that.
यस प्रकाश चौहान जी जुड़ चुके हैं।
ठीक है। और मिस्टर
हाँ डॉक्टर
राकेश
प्रकाश
जी,
चौहान जी
मिस्टर
इज।
राजीव कोठीवाल जुड़ गए या नहीं?
कौन सर?
मिस्टर राजीव कोठीवाल।
वो अभी नहीं जुड़े हैं।
डॉक्टर अमित भारद्वाज जुड़ गए? राकेश जी?
अभी नहीं जुड़े।
अमित जी
नहीं,
तो
वो
फोन।
जुड़ गए हैं शायद, देखिए। राजीव कोठीवाल जी शायद जुड़ गए हैं, देखिए।
अच्छा।
हाँ जुड़ गए।
हाँ सर।
ठीक है।
नो।
और डॉक्टर भारद्वाज, डॉक्टर अमित भारद्वाज
डॉक्टर
अभी जुड़े
भारद्वाज
या
अभी
नहीं?
नहीं दिख।
डॉक्टर
वो
राजेश
अभी नहीं दिख रहे हैं।
फोन कर लो अनिल जी। मैं इसे स्टार्ट करता हूँ, फोन कर लो, क्या करें? हेलो,
राकेश, डॉक्टर राजेश प्रकाश जुड़ गए हमारे साथ या नहीं?
अभी तो नहीं दिखाई दे रहा है कहीं।
अभी नहीं जुड़े हैं।
फोन पे बात कर लो अनिल जी, दोनों लोगों से, और स्टार्ट करते हैं फिर।
मैंने बात की थी, वो अभी जो है गाड़ी में है,
हम्म
कह रहे थे मैं आई एम ट्राइंग।
हम्म तो स्टार्ट करें फिर।
डॉक्टर राकेश अमूल्य के नागर जुड़ गए या नहीं, जो
वो
आपके
सर
कीनोट स्पीकर हैं?
वो सर लास्ट में ही जुड़ेंगे, करीब 10:50 को लगभग। उनसे बात हो गई थी, वो 10:50 के आसपास जुड़ेंगे।
प्रकाश चौहान।
वो जुड़ चुके।
हाँ, प्रकाश चौहान जी जुड़ चुके हैं।
जी।
अच्छा,
हम्म,
और मिस्टर मोरे जुड़ गए, प्रोफेसर मोरे?
अनिल जी।
नो नो।
No, still not. Not connected still.
So we start now, I think.
Yeah, start now.
Yes. So
ओके।
um, I request to Dr. V.V. Singh, Principal, Hindu College, Muradabad, please give welcome address to start the conference, International E-Conference on Emerging Advances in Mathematics and Physical Sciences. Thank you, sir. Please.
Thank you, Dr. Rakesh. It's a great pleasure for me to welcome our keynote speaker, Prakash Chauhan, IRS Dehradun, Professor Parveen S. Mohre from Mumbai, participants from all over the world. It's really a pleasure for me to welcome you to the e-conference that is taking place in very typical conditions. As all of you know, that world is passing through a pandemic, COVID-19. But this COVID-19, I presume, as a boon, otherwise this e-conference cannot happen, or we can conduct this by conventional methods. So once again, I welcome on behalf of our management committee and our host, Dr. Anil Chauhan, Dr. Rakesh Kumar, Dr. Sundar Singh, to organize this e-conference. And I hope during the tenure of 2 days, deliberations will give a very maturing results to the society. Thank you, Dr. All of you once again. Thanks, Dr. Anil Chauhan. Thanks, Dr. Rakesh.
Thank you, sir. Now I request to Dr. Anil Kumar, please give about the conference. Please start, Dr. Anil Kumar.
Good morning, everyone. Honorable dignitaries, joined with us, our chief guest of the conference, Dr. Prakash Chauhan ji, Director, Indian Institute of Remote Sensing, Dehradun. Our chief patron, Dr. Amit Bharadwaj ji, Joint Secretary, Higher Education, Uttar Pradesh. Our patron, Mr. Rajiv Kothiwal ji, President, Hindu College, Muradabad, and Chancellor, IFTM University, Muradabad. Our keynote speaker, Professor Atulya Nagar, Pro Vice Chancellor, Hope University, UK. Chairman of the conference, Dr. B.B. Singh ji, Principal, Hindu College, Muradabad. Deputy Chairman of the conference, Dr. Mukul Kishore ji, HOD Physics, and Dr. Sanjeev Rajan ji, HOD Mathematics Department, Hindu College, Moradabad. Convener of the conference, Dr. Rakesh Kumar ji. Organizing secretaries, Dr. Dilip Kumar, Mathematics Department, and Mr. Sundar Singh from Physics Department. Member of organizing committee, other guests from abroad and from most of the states of India, my colleagues, faculty members, and scholars. It is a matter of immense pleasure for me that Department of Physics and Mathematics jointly organizing an international e-conference on emerging advances in mathematical and physical sciences. Previously, these both departments have organized two UGC-sponsored national level conferences related to the same topic. So it is our third joint effort of Department of Physics and Mathematics in the direction of Festival of Academicians and Intellectuals. Actually, the mathematical and physical sciences are the backbone of engineering and technology and medical sciences. In this conference, more than 600 participants are registered, in which some are from abroad, and from registration record, I can say that no state from Kashmir to Tamil Nadu and Gujarat to West Bengal is left. Around 115 abstracts have been received to us, and around 80 out of them will be going to present. Thank you, sir.
Dr. Anil,
Yes, sir.
can you hear me?
Yes.
Now Dr. Amit Bharadwaj is with us.
Yes,
Please
sir.
welcome him.
Okay, sir. Dr. Bharadwaj ji, Dr. Amit Bharadwaj ji, Joint Secretary, Higher Education, Uttar Pradesh is with us. I, on behalf of organizing committee, welcome him. Dr. Rakesh, you can proceed.
Hello.
Dr. Rakesh.
Hello.
Yes, we are
Hello.
getting.
Hello.
Continue, sir. We are getting now.
Now I request to Dr. Amit Bharadwaj, Joint Secretary, Higher Education, Lucknow, to address the conference. Please, sir.
Am I audible?
Yes.
Yes, sir.
Yes.
President, Hindu PG College, Moradabad, and Chancellor, IFTM, University, Moradabad, Principal, Hindu PG College, Moradabad, organizers of this webinar, and all who have joined today, along with technical support persons, and all those who have contributed to make this webinar a success. It's a matter of great pleasure for me to be in the midst of galaxy of intellectuals that have joined today. It's a matter of great pride also for me, particularly because I have studied at this college. I have passed out BSc and MA English from this college. I extend my heartfelt thanks to all the organizers that they gave me a chance to be a part of this valuable webinar. I would like to thank all my teachers who, because of whom I am here where I am today. It's a matter of great pride also. I am here as a chief guest or as a chief patron. Actually, being patron is not more important for me, particularly at an institution where I have studied, where I have been a student. It's a matter of great pride also for me that I have been given a chance to speak to my old teachers, to my younger brethren, to my known colleagues. I must also share one thing with you, that I secured about 75% marks in a BSc, and I was also awarded scholarship at college level for being one of the highest scorers in my class. So it's a great pleasure for me that I am once again, though after a long time, I am here I have joined the galaxy of intellectuals, particularly with the efforts of the organizers of Hindu PG College, Muradabad. As you know, there was a time when we were used to conducting traditional classes. Students used to come to the classes, teachers used to come to the classes, they interact, they used to teach, and they used to study face to face. Now, because of this pandemic, we have found a way out to make the time of the students more useful and more productive when the entire world was at a standstill and no activities were allowed to go on. Of course, this was a good option. We were engaged in online teaching. Online teaching also made the time of our students particularly more valuable and more productive. Now, I would also like to share with the teachers and the intellectuals and the scholars who have gathered today by the medium of this Zoom meeting, this webinar. Actually, now the time has come. We have thought over, we have brooded over for a long time how to teach the students sitting at their places. Now the time has come. I hope you would appreciate my idea that now the time has come what to teach our students, particularly in order to make them capable of not only getting the jobs, but also to gain knowledge, so that they may be able to bring a great name to their nation, to their country. What to teach them? How to teach them, we have overcome, really, very successfully. Our teachers, the efforts of our teachers really commendable, and they have shown that they can do anything for their students, for their nation, for their society, if there is a time for them to do anything. It is really a success on the part of our teachers, and I consider all the teachers no less than the front warriors of this COVID-19. I appreciate the efforts made by teachers during a couple of last months, I must say. As you know, the topic of this webinar is emerging advances in mathematical and physical sciences. Mathematics, Department of Mathematics and Physics have really chosen a very, very effective, very valuable, very, very important issue, theme to organize a webinar on this. I really appreciate this theme, and I really congratulate all of you, those who have organized this webinar on this particular theme. I have also been a student of science, but though at a very low level. I just passed out BSc, and in front of the intellectuals, I went through the long list of scholars are there who are going to speak after me. That definitely we all shall be benefited by all this. Aryabhat was the first in line of great. Aryabhat was the first in line of the great mathematicians from the classical age. His work covers arithmetic, algebra, plane and spherical trigonometry. He also gave approximation of pi. The teachers or the students of mathematics may be getting me. Then I would like to make mention of Ramanujan, who made extraordinary contribution to mathematical analysis, number theory, infinite series, etc. I would like to remind you of one incident. Once Ramanujan sent a set of 120 theorems to Professor Hardy of Cambridge University. As a result of which, Professor Hardy invited Ramanujan to England to discuss several problems, and he also felt benefited by discussing those problems with Ramanujan. Such scholars we had in our country. This is a matter of great pride for all of us. One more thing I would like to make mention here, which is number is 1729. You must be understanding what I want to say is 1729 is known as Ramanujan number. Once a scholar of mathematics went to Ramanujan and he asked him, what was the number of your taxi? What was the number imprinted on the number plate of taxi? The gentleman simply said, sir, it was 1729. You will definitely be surprised to note that Ramanujan all of a sudden gave him an idea that this number can be written in form of sum of cubes of two numbers. Cubes of two numbers, I repeat. For example, 1729 can be written as 9 cube plus 10 cube. 9 cube means 729, 10 cube means 1000. The addition of 729 plus 1000 comes to 1729. Or he suggested another idea that it can also be written as 1 cube plus 12 cube is equal to 1729. Cube of 1 is 1 and the cube of 12 is 172, and again the addition comes to 1729. So such great scholars we had, such a glorious past we had of our country, and we must be proud to be a citizen that we are born in such a great country. It's a matter of great pleasure also for all of us. Then I would also like to make mention of Shakuntala Devi. Shakuntala Devi is known to be faster than the computer. Once she was given 13 digits to multiply by 13 digits. And you will definitely be surprised to know that she multiplied 13 digits number by 13 digits number in 26 seconds only, which was faster than a computer at that time. So this is the past of India. This is the past of Bharat. Then I would like to mention Galileo Galilei. He was an Italian astronomer, Italian physicist and engineer. He is also known as the father of modern physics. He studied speed, velocity, gravity, free fall, and described properties of pendulums and hydrostatic balances, and invented military compasses also. It was he who for the first time gave the military the compasses, the study of compasses, which made the life, the planning of our military so easy, I must tell you. Now, after that, the COVID-19 made the entire world stand still. We have once again come to a reopen. We have once again come to unlock, and it is the responsibility of teachers has become greater than before. It is the teachers who can, I must tell you, India had a glorious past, India has a glorious past, and India will definitely have a glorious past. And as teachers, we must own this responsibility to give India the same status once again. We, the teachers, must hold this responsibility to make India the Vishwaguru once again. I tell you, if the teachers of our nation, the teachers of our country has this responsibility to make this country, make our nation a Vishwaguru once again, we will definitely be successful. We all shall leave no stone unturned for this purpose. So once again, I would like to congratulate the organizers of the webinar, and also once again, I would like to thank you all that you gave me a chance to speak before my elder brothers. Some of you are my younger brothers, and some my teachers would have definitely joined today. I once again greet you with great namaskar. I would like to touch the feet of my old teachers, and once again I would like to thank you so much that you gave me a chance to be with you for some time. I would like to say one suggestion more. That the topic of today's webinar is emerging advances in mathematical and physical sciences. I came to know that the webinar has been organized as a joint venture of mathematics and physics, Department of Mathematics and Physics. This is really undoubtedly a valuable webinar. But for next time, whenever you have time, whenever you find time to organize another webinar, topic must be open for all. For all, I underline the word. I underline the idea. The subject or the theme should be open for all. For the maximum participation should be there. I would like to thank you once again. Thank you so much.
Thank you, sir. And I thanks to Dr. Amit Bharadwaj. He has 20 years experience of teaching and principal as administration in different colleges from place to place. Now he is working at Lucknow as a Joint Secretary Higher Education. Now I request to our special patron, Dr. Rajesh Prakash, Regional Higher Education Officer, please address.
Not available, I think, sir.
Not available? So,
yes, no, not showing.
Okay. Now I request to our patron, Sri Rajiv Kothiwal, President, Hindu College Management Committee, for their blessings.
On this occasion of this international e-conference on emerging advances in mathematical and physical sciences, I congratulate all the members of the organizing committee for such an applied and interdisciplinary event. I wish successful completion of this conference. I extend my best wishes to all the participants for learning a lot from this event. Thank you. All the best.
Thank you, sir. Thank you very much. Now I request to our keynote speaker, Professor Atul Nagarji. I first gave him. Professor Atul Nagar holds a foundation chair as a professor of mathematical sciences and is the Pro-Vice Chancellor for Research at Liverpool Hope University, United Kingdom. He has been the head of the School of Mathematics, Computer Science and Engineering, which he established at the university. He received a prestigious Commonwealth Fellowship for pursuing his doctorate in applied nonlinear mathematics, which he earned from the University of York, UK in 1996. He holds BSc, MSc, and MPhil in mathematical physics from the MDS University, Ajmer, India. Prior to joining Liverpool Hope, he was in the Department of Mathematical Sciences and later the Department of System Engineering at Brunel University, London. He is an internationally respected scholar working at the cutting edge of theoretical computer science, applied mathematical science, and system engineering, with his research expertise spanning both applied mathematics and computational methods for nonlinear, complex, and intractable problems arising in science, engineering, and industry. In problems like these, the effect is known, but the cause is not. In this approach of mathematics known as inverse problems, sophisticated mathematical modeling and computational algorithms are required to understand such behavior. He was edited volume on intelligent system applied mathematics. He is the editor-in-chief of the International Journal of Artificial Intelligence and Soft Computing and serves an editorial board for a number of prestigious journals. He is well published with over 400 publications in prestigious publishing outlets. Professor Nagar sits on a number of strategic UK-wide research bodies, including the JISC Research Strategy Group. So I request to Professor Atul Nagar, please give a talk as a keynote speaker. Thank you, sir.
Well, good morning, everybody. And thank you for that warm welcome. I hope you can hear me. It's good to see you organize this event. Of course, wish you all the best. I send you my greetings from Liverpool and my university where I'm based, Liverpool Hope University. We are a beautiful city and a beautiful university. Some of you who follow football will know that Liverpool has recently been in news for winning the prestigious Premier League. Indeed, a very important achievement for the city of Liverpool Football Club in the last 30 years or so. As a university, we are quite highly ranked in the UK for our academic excellence, for our teaching, our student-friendly approach, our traditions going back to 1844. We celebrated our 175th anniversary last year in 2019. So we are quite a well-established institution with a very long tradition. We are, of course, also very highly regarded for our research. We have We are a beautiful city of Liverpool, also known as city of music. We have beautiful campuses on which we have all facilities in one location for all our students. So it is a really nice township campus in a nice leafy area of Liverpool, where the students and staff, students and scholars, teachers, tutors enjoy being at the heart of what we do. What I'm showing you are some pictures of the campus and the university. Liverpool, as some of you know, is in the northwest of England. It's only 2.5 hours by train from London, but at least it is in a nice, quiet port area that Liverpool is, by the side of the River Mersey. So it's a beautiful city. I must say that I also have association with your city, Moradabad, because my wife belongs to Moradabad, and I have many wonderful memories of spending time at Moradabad. I indeed enjoy visiting Moradabad, and obviously when next time I am there physically, perhaps we should meet. So the topic for today that I have chosen is quite relevant to your conference that you are organizing. This is a theme which cuts across a number of scientific areas, in particular mathematical sciences and physics. So I want to spend some time this morning by talking about what is complexity, what are complex systems, what is chaos, what is a simple system, what is a complex system, and certain trends in physical sciences, which of course includes mathematical sciences. In some sense, mathematical sciences sit at the borders of humanities and sciences. So mathematics can be treated as a science. Equally, it can be seen as humanities. And indeed, mathematics draws a lot of inspiration from nature, from other disciplines. So, as I say, this topic is about an important science or important phenomenon, important aspect of science, which is complexity or chaos theory, which is the science of this millennium, in which we are living now. We know that mathematical models are everywhere, algorithms are everywhere. These can be found in everything we do. Technically speaking, some of us study theory of computation and time-space complexity. Many of us study those things. But today I want to touch on what exactly is complexity and how understanding of complexity can help us in developing the modern sciences. In some sense, the topic I have chosen today, this morning, is to motivate our young scientists, young minds, new researchers to think something creative, to be observant, to observe, and not just rush into doing something which is routine, but think innovative. So I hope that that purpose this morning will be served. Uh, I'm sure many of you will know this very, very famous name, Professor Stephen Hawking. Sadly, he died just very recently. He died, he passed away. But in January 2000, just at the turn of this current millennium, he very famously commented, very famously remarked that the past century, that is by that he meant the 20th century, was the century of quantum mechanics. And he said that the next century, that is the century we are now in, the 21st century, he said, I think the next century will be the century of complexity. So what is complexity? And how can we as scientists, as mathematicians, as physicists, engineers, even humanity scientists, liberal arts scientists, artists, people who work in social work, management, how can we make sense of this complexity? And indeed, if we can make sense of this, then how can we turn it to our advantage? How can we use it? How can we convert it into our benefit? So that is what I'm trying to delve into this morning. In sciences, there are, broadly speaking, two approaches. Broadly speaking, we can go into the lengthy debate, but I think broadly speaking, there are two ways in which scientists, not only scientists, I think business professionals, we all actually approach things, approach phenomenon, approach problems. First is the reductionism, which simply means pulling things apart and fixing it and assembling it back. So if you have a car which is broken down, you can remove its gearbox, you can remove its clutch, fix the things, put it back. You have it back, you have it assembled. So that's one approach. The second approach is a more holistic approach, or holistic approach, which is a systems science approach. In this approach, you don't necessarily break things apart. You don't necessarily pull things apart. You try to understand the system as a whole in aggregation. And in doing so, that aggregated system is sometimes much more complicated. And it's not as simple as just summing it up. So a very good example is human body. If you want to understand the patient, and in particular, if you want to understand their heart, if they have a problem, a heart problem, then obviously you're not going to take the heart out of the body and fix it and put it back. Well, you may want to do that, and that may be possible, but a medical professional will want to treat the patient while the heart is well within where it should be. And that is a holistic approach. So what is a complex system? Does a large, complicated looking system with many intricate or interacting parts make it a complex system? So is an airplane a complex system? Perhaps for an aeronautics engineer, it is not. For me, it is. I'm a mathematician. I'm not an aeronautics engineer. So for me, it can be a complex system. It is complicated, perhaps even. But I want to show you this morning that it is not only systems with such intricate arrangements, intricate parts, many interacting things that make a system complex or complicated. But I want to show you this morning that even simple, deterministic, not stochastic, deterministic systems can also exhibit complex system behavior. That is what I'm trying to lead us to this morning. I of course drive car, but when it breaks down, I think it wise to take it to the garage because I'm not a mechanic. I can't fix it. It is too complicated for me. But for a mechanic, for someone working in a garage, it's not a complex thing. They will fix it for me. But I want to show you this morning certain phenomena which are rather complicated. This is the undercarriage of an aircraft. And that picture that you are looking at, simulation, is known as the shimmy behavior. It's a shimmy, that kind of vibrating of the vibrations in the undercarriage wheel of the aircraft. Now, in order to understand that, the aeronautics engineer needs to look at the holistic system, not take the undercarriage wheel out, because the wheel itself will not display that. It only happens when the airplane is taking off or landing. And there are numerous such things. Our wristwatches, our cars, which have so many intricate parts. Complicated they may be, but complex perhaps they are not. And I argue that there are certain characteristics which make a system complex. And so there is a long list and I can go on and on. But I want to argue this morning that there are three important fingerprints, three important characteristics, fingerprints, which make a system a complex system. And these three are irreducibility, adaptability, and self-organization, and a very, very, very important one called emergence. Those three. There are many more, and I have listed there, but many of those things are consequences of those three. The power law, the scale invariance, non-linearity, singularity. I'm a mathematical physicist and I study cosmology. And there is a concept of singularity in the cosmology that exhibits a complex behavior. But I would argue that all of those things are a result of those three. So let us this morning spend a few minutes each on each of those three important characteristics. And in doing so, first I want to start with irreducibility. As it says, as the word implies, complex systems come as a whole. Remember the holism, the holistic approach. Complex systems cannot be studied by breaking them into constituent parts and then trying to look at the individual parts. The behavior of the system is indeed manifested by the interaction amongst the parts, and any attempt to tear that, to break that into pieces will destroy the very phenomena that you want to study. So if I come back to my aircraft undercarriage wheel, that shimmy behavior is only seen when the aircraft is landing or aircraft is taking off. So if you just wanted to take that undercarriage wheel out of the aircraft and try to understand that, it simply won't work. It just simply won't work. So that's the first one, irreducibility. The second very important one is adaptability and self-organization. And what does this mean? Well, certain systems, certainly systems which exhibit complex behavior, they have the ability or capability of to learn from the environment and change their behavioral response in light of new information. Adaptable and self-organized systems. Many of us, when we were kids, I think even now, we observe this. When we were kids, we used to play with sand. Many of us have poured the sand in one place. If you pour the sand in one place, what happens is you see a mountain starts to emerge. A mountain. You keep on pouring sand. There will come a critical point after which there will be a number of avalanches and the surface will become flat. You keep pouring more sand, the mountain will keep on growing. At certain point, again, a critical point will reach. There will be a number of avalanches and the surface will flatten. We do this, we fill all the time, we fill the wheat flour, the atta in our containers. We observe this, we fill sugar in a box, and we observe this. Kids play all the time with this, and such a kind of a wonderful example where the adaptability and the self-organization can be seen. And perhaps the most important one, probably the single most, if this has to be present in a complex system, this particular fingerprint or characteristic is known as emergence. You know what emergence means? Something happens as a result of certain actions or steps or event. Complex systems produce surprising behaviors. In fact, they produce certain patterns, certain behavioral patterns, and indeed properties that one cannot just explain or predict from the knowledge of their constituent parts. Let's take a very good example of water. What is water? Water is H2O, two hydrogen atoms, one oxygen, H2O. We know that. We have studied it since our early school days. Hydrogen is used in certain things, but pretty much it's not that useful gas. Of course, oxygen is. We breathe oxygen. But you combine two hydrogen, one oxygen, you get water. And if you have lots and lots of water, you get floods. The hydrodynamics properties of water can cause erosions on the coastal areas. They can erode rocks. None of that property you see in the hydrogen or oxygen molecule on its own. So if you remove these things apart, you don't observe that phenomenon. But taken together, you observe the emergence of something which is completely different from or even not observed in the constituent parts, oxygen and hydrogen. Take many other examples. I mean, take a semiconductor device, silicon, germanium. These are useless materials, but you combine them together, you have semiconductors, which are used in our mobile phones and in our computers. And we all are perhaps online this morning because of that semiconductor device running underneath our electronic gadgets. So the emergent behavior simply means that the whole is not only more than the sum of its parts, but can be very different from its parts. This is where 1 + 1 is not necessarily 2. It can be very different. So emergence arises from the way the components interact with each other, the way the hydrogen and oxygen interacts, germanium and silicon interacts. and they give rise to nonlinear behaviors, nonlinear patterns, including chaotic behavior. In fact, recessions and booms are emergent features of national economies. Currently, we are going through a pandemic worldwide. And what we see is the emergence of a behavior across the globe, which has resulted into a recession. In fact, after a certain point, this emergence leads to new principles, new observations, new laws, new physical laws, new laws of physics, for that matter, mathematics. And indeed, it is a one-way traffic. The new principles, and in the sense that the new principles and features may be sometimes deducible from, it can be deduced from, but not necessarily reducible to those operating at the lower levels of complexity. So let us make some observations then. There are numerous examples of complex systems around us. Some are human-made, human-engineered. Others just appear in the nature, natural ones. Pandemic is a natural phenomenon. Weather is a natural one. There are a few human-engineered ones. Let's look at that. Let's start with life. You and me, we all have 75 trillion cells within our body. The cells are doing what they are supposed to be doing. Old cells are dying all the time. New cells are created. And all this happens in such a manner that in less than 2 years, you and I, we will not have a single cell that we have today. But I still remain who I am. You remain who you are. How is this possible? Even though each of our cell contains your entire genome, you would hardly say that any one of your cell, only one single cell constitutes you. If you took one cell out of your body and you said that's me, it doesn't work like that. But taken together, the ensemble of these cells makes what you are, what I am. Weather is a very good example of a complex system. The most pervasive example, before I come to weather, is biological evolution. Around, as we know, around 3.5 billion year journey from a single blue-green algae, which resulted into or emerged into a variety of life forms. And all of that happened as a result of reproduction, mutation, natural selection. That has not required any outside agency to guide it. Now, excuse me here, because I'm not implying here, I am of course, a spiritual and religious person, but I'm only talking here from the point of view of the scientific observations. And that is a different debate for another day, the religious aspect of it. But you can see here the evolution leading to emergence and as a result, adaptation and self-organization. Another very good example, some of you will have observed, and some of you who are computer scientists who do programming will have come across this. The flocking behavior of some species. I think if you have looked at birds or starlings, if you have seen these beautiful patterns that they form when they fly, when the birds fly, they fly together in a flock. And there is a saying, birds of a feather flock together. There is a very famous saying as well. The birds flock together. They form a beautiful pattern. How is it happening? Well, there is no king in that flock. There is no queen. There is no traffic policeman. They don't have a road map. They don't have a plan. They work on three very simple behavior things they do. Separation. Separation simply means steer in such a manner that you don't crowd the local flockmates. Keep appropriate separation, social distancing. Human beings, we fail to do that in the times of pandemic, but look at the birds. They can maintain social distancing. Steer to avoid crowding local flockmates. That's the first one. Alignment. Steer towards the average heading of local flockmates. They don't have any traffic rules or any road maps. As I say, there is no policeman, there is no policewoman. Just alignment into the average heading of the local flockmates. And the third one, very important one, is cohesion. That is, move towards the average position of local flockmates. In this, you see all those three hallmarks. Irreducibility. If you take one bird out of that flock, that single one bird will not exhibit that phenomenon anymore. That beautiful pattern that you see, that won't be there. They use the visual clues. They use they influence the air current when they, with their wings. They are self-organized. No policeman, no blueprint, no plan, no roadmap. As a result of all of that, what do you see? You see emergence of a beautiful pattern. So very good example from nature. Same thing happens in termites. I'm sure you know termites, the deemak, with what you call it in India. When you go from one place to another via road, you come across these type of things. These are made by the deemak, the termite, and the ants and other animals as well. Swarm. It's a big band, but no conductor. There is no conductor there. Swarming is a very well-known behavior in many animal species. Locust, they have swarming. School of fish have that. Flocks of birds. Again, you see emergent structures as a common strategy found in many such animal groups. Ants, molds of termites, swarms of bees, shoals or schools of fish, and so on. Absolutely no traffic lights, no blueprint, no policeman, no policewoman, no king or no queen. Let's then take some human engineered systems. I'm sure many of you are familiar with this terminology, nanotechnology. Many of you who study physics study this technology, this particular phenomenon, nanotechnology, which is nothing but study of control of matter on an atomic and molecular scale. What is an atomic and molecular scale? It is 100 nanometers or smaller. That's what it is. And what is nanotechnology? It is a human engineered process. It is a process of manufacturing material using an approach which is based upon molecular self-assembly. Molecular self-assembly is nothing but a process by which molecules adopt certain defined arrangement, which actually does not require guidance or management from outside source. And you know that nanotechnology is going to change the way technology works. They are talking about small nano robots which will cruise up and down the bloodstream of patients and cure certain diseases. So medical applications of nanotechnology. Graphene is a fine example of nanotechnology, which will change the way artifacts are made. Atmosphere and climate are example of complex systems. Cyclones, tornadoes, these are all emergent behavior, which of course result because of the motion of air particles on the earth, which is spinning, and the air pressure, the sun, intensity of sun, carbon dioxide levels. So there are numerous such examples, natural ones and human engineered ones. The point is that those three characteristics are exhibited, are there. All of these systems require sophisticated mathematical approaches. Mathematics is well developed. The apparatus is there. Mathematical apparatus is actually very sophisticated and very well developed. That's the real challenge for us as scientists and engineers and physicists is to actually model, produce simple, understandable, clear models, mathematical models, and computational models, and analyze those things. You are in India, you know the Indian traffic. There are no traffic rules. You can't simply apply any traffic rules. The crowd behavior, the chaos on the road, but out of the chaos you see order out of disorder. And that is a very good example of a complex system. You see here irreducibility. You can't just take one three-wheeler out and then try to study what's happening on the road. You have to understand the entire traffic system as a whole. So irreducibility. Self-organized. It is a self-organized system. When you drive, you follow the road patterns, you follow the traffic patterns, and we all reach home. Sooner or later, we all reach home. As a result of that emergence, what do you see? You see an order out of the disorder. And indeed, crowd modeling, mathematically modeling crowd is a hot topic. Many of my colleagues here do that. I myself have done some work in this area. And understanding of that does require mathematical computational methods. Again, in the Indian context, you know Kolam, of course Kolam is in South India. In North India you call it Rangoli. These beautiful patterns, there are applications of these very simplistic looking patterns. They are simple patterns. There's nothing uncertain or stochastic about these things, but these have applications in picture grammar, computational mathematical models for defining, for generating picture grammar. And again, there is a lot of research work that I have done with my colleagues in India on picture grammar that you can see on the internet. So as I started by saying that it is not necessary that only complex systems behavior, complicated looking systems behavior, complex phenomenon, even simple systems can exhibit complex behavior. Now, all of you have studied this in your, schools, 10th class or 12th class, wherever. Simple harmonic motion. Galileo was mentioned this morning. Galileo discovered this in 1602. You know what the simple harmonic motion looks like. It is a pendulum found in our grandfather's clock. It is a sinusoidal function. The simulation is shown there. Nothing stochastic about it. It is a deterministic system. There is no uncertainty here. It's a deterministic system, very simple system. Or indeed, you can model it. I'm showing you the simulation of this simple harmonic motion. There are different ways you can do these things. Now, what I want to do is I want to take the simple pendulum, but I want to attach to that pendulum another pendula. So you can see this upper part in black and the lower part in yellow or gold. So I have attached that. And here I want to show you some video. So I want to, I will come out of the PowerPoint. I will show you some video. First, let me show you this video here. I hope you can see it. So here is a simple pendulum, and it shows the simple harmonic motion. So that's the simple harmonic motion that you are looking at now. See? Okay. Now what I will do is I will open the pendulum. I will attach the two pendulum, and I will give it a motion which is in phase and out of phase. So in phase and out of phase. Now I will give this pendulum a very vigorous motion, and you see what will happen. It will demonstrate a chaotic behavior. Now, indeed, what we see here is, a chaotic pattern behavior. Now, let me just show you another video. No matter how many times I do this, so here is your simple pendulum. This is a simple pendulum. Let us now make a double pendulum. So this is a double pendulum. You can see the chaotic behavior. Okay. Now, if I just take two pendula together, so here you will see now two pendulum taken together. For a while, they will follow the same trajectory, but after some time, after a while, they will go their own way. Completely chaotic. Now, what you can do is, of course, you can do these experiments in your laboratories. You can try to, do it in a vacuum. But what you will see is that this double pendulum, this is known as a double pendulum. This double pendulum is a very good example of complex behavior in a simple, I want to underline, simple coupled system. It is still a simple system. It is not a deterministic system. And that unpredictable behavior you see is because of the coupling. It is because of the coupling. It is the coupling of pendulum, which you can see here, screwed to another pendulum. So that coupling brings about this chaotic behavior. And of course, you can model this. Is a differential equation. I do a lot of nonlinear differential equations. You can model it. Here it is. And what you see, and you can simulate it in MATLAB or whatever you want to simulate in. You will get here Euler-Lagrange differential equations. You will get, those of you who study mathematics and physics will have come across this Euler-Lagrange differential equations. You see here irreducibility, self-organization, and emergence. The thing with this system is it is deterministic. It is not stochastic. Newton's law apply, but there is a sensitivity to initial conditions. Even if we have exactly the same initial conditions, you will get totally unpredictable, unrepeatable behavior. And indeed, this is a There's a very active area of research in mathematics known as boundary value problems or initial value problems, even integral or integral differential equations. So it's the coupling which brings about that complex behavior in a simple system. The system does not necessarily need to be too complicated. Some of you will have come across Edward Lorenz. Lorenz was a professor at MIT. In 1963, he was trying to understand weather. He was forecasting weather, and he was using those set of differential equations that you see on the screen. He was using a computer, a computational model. One day he was going to a meeting and he was in a hurry. Meeting, what he did was he started the simulation, but he truncated the parameter, that green, decimal number. He truncated it off and he just inputted 0.506, which is a difference of only 1%, you can see. And he went off to the meeting. When he came back from the meeting, he was surprised. He was absolutely got smacked. He mentioned that we had been used to thinking that large changes need large forces, but he found that small forces could have large effect. Small forces could have large effect. This is known as butterfly effect. I will come to that. Butterfly effect is only a metaphorical description. A tornado cannot be formed just because the butterfly flaps its wing. But this is a very famous paper by Lorenz, in which he wrote, and I'm not going to read the entire thing, but he writes that how he was going to a meeting. He had a computer in his office. He put some initial conditions, truncated it, but soon when he came back, he saw that small differences had amplified, and he was getting completely different results. These small errors in observation had amplified until they became very large. Indeed, those of us who are mathematicians, we have all done this in our school days. Here is a simple simultaneous equation. Solve it using paper and pencil, and the answer you will get is x equal to 1 and y equal to 3. Now, the modern computers and calculators are very good, are very sophisticated. But if you have in your house a very old computer or a very old calculator, by old I mean 1970 or 1980s calculator or a computer, if you try to do it on those old computers, you will get a completely different solution. And this is because the modern computers are very good in terms of dealing with the floating point decision, floating point estimates. But the older machines were not that sophisticated. In fact, what was happening is, and here is a very good example, small changes lead to big differences or gains. You see, you can raise 1 to the power of 365 and you still get 1, but raise 1.01 to the power of 365 and you can see the gains there. So doing nothing at all versus small constant changes. This is a very good and a very simple example of how the errors can add up if you are not careful about your simulations. So just to recap what I have talked about, I talked about examples like ant colony or termites or flocking behavior of birds. Some of us who are computational scientists, we use these algorithms to mimic these algorithms, artificially mimic these algorithms to solve intractable problems, difficult problems. These are known as flocking behaviors or flocking algorithms or ant colony optimization, etc. I work with colleagues in India who specialize in soft computing, and we are using these types of nature-inspired algorithms. So that's one aspect. The other aspect is, if we are not careful in our numerical simulations, we could end up with a disaster. History is evidence of that. So some real life experiences of bad computational or numerical computing. We all do numerical computing these days in mathematics. Remember the sinking, those of us who are old enough will remember sinking or collapsing of the oil rig off the coast of Norway. That happened because the value 1 by 10 in a binary number system, of course, in binary number system, you don't have a decimal point, you have a radix point. That error resulted into accumulation of errors. That small, tiny, minute error resulted into a huge kind of built up of errors, and that oil rig collapsed. Ariane 5 rocket blasted off after the liftoff at the coast of French Guiana. And that was again just minor computational error, which is a very good example of a complex system. And billions of US dollars were gone. So small changes in the initial conditions can produce major and unpredictable quality changes. Yes. Am I supposed to be finishing soon? Okay, I'm just about to finish now. So
आपने इसमें इनको दबाना पड़ता है मोबाइल के अंदर, जिस समय जोड़ते हैं नीचे ऑडियो के लिए वो मैसेज आता है, वहां दबाना पड़ता है, तब आता है.
Okay, so this phenomenon. Excuse me, somebody is talking quite loudly.
जैसे हम लिंक करते हैं तभी एक मैसेज आता है, उस पर दबाना पड़ता है.
Can you please mute your microphone if you are talking to somebody?
Continue, okay. Sir.
Yeah, this particular phenomenon is known as the butterfly effect. Lawrence actually wrote a very seminal paper. The paper was called Predictability. Does the flap of a butterfly's wing in Brazil set off a tornado in Texas? It does not. This is just metaphorical. For us as mathematicians, we call it the sensitive dependency on initial conditions. So this is known as sensitive dependency on initial conditions in mathematics. And a very famous cartoon that was published in the New York Times, I think. And there are numerous examples. Henry Poincaré and his work, the many-body problem, the three-body problem, is a very good example in mathematics, which is a complex system which gave rise to the whole theory of complexity. Some of you, as mathematicians, perhaps study bifurcation theory. Bifurcation theory is based around this work that Henry Poincaré started. Emergent systems, very important example this is. A very, very small small piece of research by Mobius, by a German scientist, Mobius, resulted into Mobius strip. And that resulted into the whole new world, the whole new subject in mathematics known as topology or topological analysis. So such is the importance of these small changes resulting into big impact. Power laws, we study power laws in physics, we study power laws in mathematics. A very good example of emergent systems. We see numerous examples of scaling laws, which is complex system. The internet is a very good example, studying pandemics or epidemics or pandemics. COVID-19 is a very good example of a complex system behavior. Some of my colleagues from South Asia University in India and IIT Roorkee, we are working on modeling COVID-19 using nonlinear differential equations and their solutions using soft computing methods. So a very good example there of scaling DNA sequences, understanding of the DNA sequences. I'm not going to go through this because I'm conscious of time, but a very good example of a mathematician who was challenged. G.I. Taylor was challenged by the US when he published the classified secret of the first hydrogen bomb. He was challenged, but he was a mathematician. He did not break any secrets. He simply mathematically computed the energy of that hydrogen bomb. US government was surprised, but G.I. Taylor, a mathematician, rebutted their claims by saying that, look, I don't know what the energy of the hydrogen bomb was, but you have just confirmed it. I only merely computed using the power laws. I computed in a small experiment in my laboratory at Cambridge. I was able to compute the energy of the hydrogen bomb. Such a wonderful example. So just very quickly then, why do we need to understand complex systems? As I mentioned, the mathematics is very sophisticated, but understanding of these things, stock markets, natural disasters, pandemics, is very important for the humanity. How do microbes evolve, antibiotic resistance, how do pandemics develop, robotics. The next few years are going to be the years of artificial intelligence and robotics. How do we combine genes that affect a person's likelihood of getting heart disease, for example, genetic therapies. All of those things require sophisticated understanding of mathematical behaviors.
Excuse me, sir.
Yes.
Sir, please conclude it.
You okay? Am I supposed to be finishing?
Yes, sir.
Okay, I'm just give me a couple of minutes, I will finish. So there are numerous examples of applications, computer games, fractals are a very good example. The overall aim is not to create a complex model, but to create a useful model, simple model that helps to understand complex phenomena. Self-aware skin, self-aware healing materials for aircrafts, for example. All of these are examples. At my own university, we are doing a lot of research work in this area. We've got a number of PhD projects. We have a vibrant master's program. Now, I won't go through all of those. I'm happy to answer any questions, but just to take you through a very good poem we all studied when we were in schools. And this poem shows the dependency of events and phenomena upon initial conditions. And this has been long recognized. We all studied this in our English textbook. For the want of a nail, the shoe was lost. For want of a shoe, the horse was lost. For want of a horse, the rider was lost. For want of a rider, the battle was lost. For want of a battle, the kingdom was lost. So remember, small changes make big differences. I'm happy to take any questions if there are any.
Hello.
Yes.
सर कोई क्वेश्चन पूछना चाहता है क्या? हेलो अनिल जी. So I think there is no question. Thanks sir, बहुत अच्छे आपके इस लेक्चर के लिए. And I think that everyone have enjoyed the lecture. And once again, I thank you. Now I request to Dr. Anil Kumar, please take over the next session. Dr. Anil Kumar.
Well, thanks very much for the invitation, and I wish you all the best in your conference.
Okay, thank you.
Take care. Bye-bye.
Bye. Dr. Anil Kumar ji.
Thank you, Dr. Rakesh.
Yes.
Thank you, Professor Atul Langar ji, for very interesting lecture. Now, I am going to invite our chief guest, Dr. Prakash Chauhan ji, for his lecture. Dr. Prakash Chauhan obtained his postgraduate degree in applied geophysics from Indian Institute of Technology, Roorkee, and PhD in physics from Gujarat University, Ahmedabad. Prior to joining Indian Institute of Remote Sensing, IIRS, Dehradun, he was the group director at the Space Application Center, ISRO, and Ahmedabad since 2014. He joined Indian Space Research Organization in 1991 as scientist, and since then working for the application of remote sensing technology for natural resources management, for ocean and land resources. He initiated research activity for planetary remote sensing at Space Application Center to study solar system objects, mainly Earth, Moon, and Mars, through Indian planetary missions. His major achievements are in the area of Earth observation applications, including development of algorithms for ocean color parameter retrieval, marine living resources assessment, aerosol remote sensing for space-based air quality monitoring, river and reservoir water level estimation using spaceborne altimeters, and coastal zone management. He has done lead work in using the hyperspectral data for
Hello. So I think Dr. Anil Kumar ji has some problem. Please start, Dr. Prakash Chauhan ji.
minor logical map.
Yes, sir. Please start your lecture, sir.
Okay.
Okay, sir.
Am I audible?
Yes, sir. Yes, sir.
And can you see my screen also?
Yes, sir.
Okay. All the dignitaries for today's this international e-conference meeting on emerging advances in mathematical and physical sciences, which has been organized by Department of Physics and Mathematics, Hindu College, Moradabad, Dr. Singh, Principal of Hindu College, Dr. Anil Kumar ji, other dignitaries, Professor Atul Nagar, Professor More, and all the colleagues, those who have joined today's meeting, a very warm welcome and good afternoon to each one of you. I am personally privileged and honored to be part of this particular webinar series. And I thank Dr. Anil Kumar for inviting me to this meeting so that I can meet all of you and share my thoughts on the work which we are doing in the field of space sciences in India. My association with Hindu College is also important. Of course, many of you may be knowing, and if you are not knowing, I belong to Moradabad city. Moradabad is my hometown, and I have, done my schooling from Moradabad. I have done my graduation from Moradabad. Of course, not from Hindu College, from KGK College in Sciences. And then I moved on to IIT Roorkee. Those days it used to be called University of Roorkee. So I have a close association with the city and I keep on, my home is there. My parents are living. So every 2 to 3 months I am in Moradabad city. So that is also a good reason to get connected with all of you. And thank you, Anil Kumar ji, for inviting me today for this meeting. Now, since the topic of Today's presentation is on the advancements in mathematics and physics. So what I thought that since the STEM education in India is very important, and many of our students coming out of 12th standards are very much keen and eager to take science, engineering, and technology as their career. And even our own city, like Moradabad, is producing a lot of brilliant students, those who are going every year to IITs, NITs, in medical colleges. The STEM education is very important today in the country. And, there are different type of applications of mathematics and physics. Professor Atulya Nagar showed in the previous examples how the complex systems work and how we can use mathematics and physics to simulate these complex systems and find answers. One of the most complicated systems which India has ever, has ventured into in the high technology area of space science and technology. Space technology and space science is considered to be the last frontier. सबसे आखिरी मुकाम जो टेक्नोलॉजी का है उसका जो कल्मिनेशन है वो स्पेस साइंस एंड टेक्नोलॉजी में होता है. In space missions, you cannot even think of having committing a 0.001% of error. If your rocket is going to take a satellite into the space, and if you have even the minutest of error, even 0.0%, 0.01% of error will lead to failure of your mission, as has been also showed in the previous presentation. For science, for physics and mathematics students, those who are interested in doing applied research, this area is a very important area, and India is a world leader in space science, technology, and applications of space science for societal benefits. In fact, we are among the first top 4 or 5 countries in the world in terms of developing space-based endeavors in this country. And recently, many of you must have seen the announcements which has been made by Government of India that government wants more public participation in the field of space science and technology and space enterprise. And space is now being opened up for private sector participation also. So in today's talk, what I will tell you is that how we are using the space science and technology for the benefit of common man, the आम आदमी जो हमारा सड़कों पर है, हम सब लोग और सारे इस देश के लोग किस तरह से स्पेस साइंस और टेक्नोलॉजी को अपने जीवन में यूज कर रहे हैं, उसके बारे में मैं आज आपके साथ थोड़ा अपने विचारों को शेयर करना चाहता हूं. First of all, let me extend again my warm welcome to all of you from the foothills of Himalaya. I currently is located in Indian Institute of Remote Sensing, which is Institute of Indian Space Research Organization in the northern part of the country, located in Dehradun. And this is our campus, a beautiful campus. And this particular campus is dedicated to space science and technology education. See, ISRO has presence in India all over the country. Most of the ISRO institutes are there in the southern India. There are a couple of them in the western part of the country, also in Ahmedabad and Udaipur. But in North India, except in Dehradun and in Chandigarh, ISRO does not have much presence. But Indian Institute of Remote Sensing has a very old history. It is more than 50 years of old institution, and which is dedicated to providing the quality education in terms of in the field of space science and technology, and particular to what we call as Earth observation or remote sensing technology. Let's begin that. What is space? What is the definition of space? Many of you may be knowing that what exactly what we mean when we say what is space. But if you see the surface of the Earth over here, the first few kilometers from the surface of Earth, if we rise, if you talk about aeroplanes, they normally travel at a distance from 10 to 15 kilometers from the surface of the Earth. So you have this lower, layer called troposphere, and then you have the stratosphere, and then you have mesosphere, and you have the thermosphere. And then around 100 kilometers or so from the surface of Earth, the density of the air molecules starts becoming very less. The most densest layer is our troposphere. And as we rise from the surface of the Earth and reach around 100 kilometers or so, the density of air molecule is very, very thin, and the light which is coming from the sun, it stops scattering. These molecules which are present in our atmosphere, the molecules of all the gases like nitrogen, oxygen, and then the other minor trace gases, they scatter the light. And the molecular scattering, as many of you physics students may be knowing, is defined by a principle called Rayleigh scattering. And the Rayleigh scattering phenomena basically gives the color of the sky. That means the molecular scattering is very strong in the shorter part of electromagnetic spectrum. And that is why most of the light in the longer wavelengths like yellow, green, and the red part of electromagnetic spectrum will be scattered, and only the blue light will be remaining. And that's why we see that on a very clear day, the sky appears blue. So as you start going up into the space, up into the atmosphere, after some time, the molecules are not there, the light is not scattered. And at that layer, we start calling, that location we start, calling a space. So space is the zone above, around our planet where there is no air to breathe or to scatter the light. Space is basically a vacuum space, but of course it is vacuum, but it's far from empty. There are theories nowadays where people are talking of dark matter and dark energy, and we have to yet understand this. But that's the area where we normally operate. That's the area where space scientists do their business. They put satellite systems, they put observation systems at that height, and then start observing the Earth, as well as they start observing the exterior part of our solar system. In fact, the entire astronomy and astrophysicists, they start looking upward, but those who are earth scientists, they start looking towards the Earth. So that's how our entire business of satellites and making observation about Earth or making observation about other planetary system works with. Now, just to give you some idea that what is the India's space program and what are the dimensions. In fact, this year we have completed 50 years of space activity in space in India. In 1969, formally, the Space Department was inaugurated by Government of India, and we did a very humble beginning. Many of you must have seen these pictures. The earlier space scientists carrying rockets on bullock carts, cycles. In fact, there are images of Dr. Kalam when he used to work in Tumba and used to carry the parts of rockets on cycles. So from those days, India has come a long way, and today we have a very, very diverse space program. If I have to say that there are 4 pillars of space activity in India, one is called space transportation. That means if you want to reach to these heights where the satellites orbit around Earth, there are 2 popular orbits. One is called the polar orbit, where we put a satellite into an orbit around 400 to 500 kilometers from the surface of Earth. And these satellites, they move from pole to pole, from North Pole to South Pole. And then we have another orbit called geostationary orbit at around 36,000 kilometers from the surface of Earth. If you put an object, it becomes stationary to the Earth motion. And constantly it will see that particular area. Suppose we want to see India 24/7, then we have to put a satellite over the Indian landmass at around longitudes from 80 degrees to 60 degrees, and we will be able to have the complete coverage of India 24/7. So these geostationary orbits, they are used for communication purposes as well as for doing meteorological weather forecast and weather observation system. So we have now well-developed space, rockets which can carry these satellites into these heights at around 800 kilometers to 36,000 kilometers. So we have very popular rocket called PSLV, Polar Satellite Launch Vehicle. It's an operational system. More than 50 launches of PSLV has been successfully done. Then we have Geostationary Launch Vehicle, GSLV. The previous Chandrayaan mission was carried by this GSLV. It's a Bahubali rocket. This rocket has a lifting power of more than 4,000 kilograms of objects. And then we are also working on reusable launch vehicle technology and the modular launch vehicles, which you must have seen, like SpaceX, etc. Recent launches were done. So India is working on to develop this technology. Then, of course, the space infrastructure. We have to create assets in the space. That means we have to put satellite systems to do Earth observation. We watched regularly our own Earth. Many of you must have seen the recent images of our China, India region in Ladakh, etc. So there are very high resolution satellites available today. They have capability of seeing 30 centimeter objects. You must have seen that people are showing on television over Galwan area, the tanks, and then even the vehicles of different armies, and then the activities which is basically happening at a very, very remote area can be observed by this type of satellite system, which is having now imaging capability of 30 centimeter or so from the height of around 500 kilometers. Then of course, for communicating the information and signals, we have this communication satellites. Many of you, if you are using your mobile phones, you are seeing the television news, especially through DTH, direct to home services. The antenna over your rooftop is directly connected to a satellite which is there in the geostationary orbit. So for communicating the information, satellites are very much used. If you draw your money from your any ATM, these ATMs are linked with VSAT terminals, which basically works from the space technology or the satellite technology. Then you have the third category of satellites called navigation satellites. Today, with a smart mobile phone in everybody's pocket, these smartphones carry GPS receivers. So आप जहाँ कहीं भी जाते हैं, you turn on your Google Navigator. If you go to Delhi, Mumbai, or wherever, if you don't know that address, you turn on Google Navigator, and that will take you to your respective location. So that behind this is the GPS technology or the space technology, where for each and every moment, your location, your latitude and longitude and height from the sea level is monitored, and you will be carried to your location using this navigation system. So India also has its own navigation satellites. It's called Navig. We have 7 such satellites in the orbit. So apart from GPS today, we have also our own capabilities. And these capabilities has been developed for military purposes, for a strategic purpose, as well as for the civilian applications also. And of course, the fourth segment is the space science and planetary mission. Now, we humans have a tendency. The early humans started exploring the solar system. In the morning talk, we talked about Galileo. Galileo was the one who developed the earlier telescopes. They started observing moon. They started observing other planetary systems in our solar system. And then now we are also talking of exoplanets in different galaxies, as well as around different suns in the universe. So India also has a very well-developed space science and planetary exploration program. Many of you must have heard about Chandrayaan-1 mission, Chandrayaan-2 mission, Mars Orbiter mission. All these missions which we are sending to understand more about Moon and Mars and other planetary objects in our solar system forms this part of space science and planetary exploration. So in each of this, all the elements of mathematics, science, solid state electronics, chemistry, many parts of basic sciences will be utilized for developing the hardware, for developing software, for developing applications. And then third important part is the space applications. Once you have launched this satellite into the orbit, what is the use of this satellite system? How you develop applications which are useful for common man? So today I will show you, my talk will be focused on applications only, how we are using this data for socio-economic development, for our farmers, for our fishermen, for our common people like you and me, for providing tele-education, for providing telemedicine, for the people, those who are living in rural areas in India. And of course, large amount of data is also used for disaster managements like recent cyclones. Nowadays, the casualty among, due to the cyclones in India is very, very less, because we have developed early warning systems for cyclone monitoring. We have developed early warning system for landslides. We have early warning systems to provide warn our people for flooding. So all these type of applications are now being developed using where the space technology is providing a very important role. And of course, we are also developing synergistic applications where both Earth observation, remote sensing data, satellite communication data, and then the GPS or navigation data is being put together, and wonderful applications are being developed where people can get a lot of solutions. The fourth segment where we are also involved in Dehradun is on capacity building. India is a large country with a very large population. So why this technology should be there only for very few people? So we need to have, a lot of trained persons. We need to have human resource development. A lot of training is required. We are talking to ministries now. More than 65 ministries of central government is using space technology, but many of them, their personnel, they don't know how to use these satellite observations. Knowledge नहीं है, तो उस knowledge को बढ़ाने के लिए हमने training courses शुरू किए हुए हैं. We have also started education programs where students are giving masters of technology or MSc degrees, how they can use these technologies for developing commercial ventures now, startups, etc. Now, a lot of young people are developing their own companies. They are developing their own startups and earning good amount of money, not only giving jobs to others, but not only giving employment to himself, but also providing a lot of jobs to the other young people. So ISRO is also very much involved in developing capacity, both in terms of human resource development as well as developing indigenous technologies, technologies made in India. Today, there is a large emphasis on, made in India as well as on Atmanirbhar Bharat. ISRO has been working to achieve these objectives since last 50 years. And entire space program in India, you can say that it's mostly indigenously developed and done by the students of colleges coming from colleges from small and mid towns. You will find, if you see the profiles of a lot of people in ISRO, you will not see many IITians in ISRO, but you will see a lot of people coming from NITs, from local engineering colleges. So I can proudly say that ISRO's program is built by students, youngsters coming from small towns, villages, and rural India. That is the beauty of India's space program. And we also do a lot of interfacing with industry, with academic institutions like university and colleges. We also provide funding to a lot of university professors and university students to carry out advanced research. And a lot of energy is also put by ISRO to outreach programs. That means to tell about the ISRO's activities to the common people. And now we have also come onto the social platforms like Facebook and Twitter to give information to the citizens of the country that how the space activity in India is being performed. So this is just an overview about the space program of India. Very quickly, I will tell you that how we are using. This is just to tell you that what kind of satellites we are operating in the orbit. We have satellites for natural resource management. That means if you want to know that which area is covered under what crop during which a particular time, we are able to tell you today that how much area is there under wheat, how much area is there under rice, how much area is there under onion, how much area of India is having the forest cover, what type of forest is present at what location. We are able to tell you about the information about water resources. I will show you some examples of water, how the water counting is done using the space images. So there is a set of satellite systems which are basically meant for natural resource inventory and disaster management. Then India is a developing country. We are also providing a lot of data for planning and cartographic purposes. That is for map making. So high resolution data, 1 meter and below spatial resolution, is used for planning purposes as well as for developing new industrial hubs in the country. Oceans, India has a large coastline, more than 7,500 kilometers. India's coastline is available for a lot of resources. So we are having large amount of resources, both living resource and non-living resource like fisheries, etc. So satellite images are today being used by fishermen in the country to find suitable locations where they can have more fishing. And for that purpose, we have developed satellites which help our fishermen. And then, of course, the most important thing is the weather and climate. You see, weather is a day-to-day changing phenomena, and then severe weather events are increasing every year. Suddenly you will find there is a flash flood. Suddenly you will find there is a lightning happening, then cyclones are happening, and then severity of these weather events, you have to keep an eye. And today India operates 2 satellite systems from 36,000 kilometers, and India Meteorology Department is continuously using the satellite observations, which tells you about what type of weather patterns are developing. And that is why you must have seen that weather forecasting capability in India has increased significantly. If IMD says that this area is going to be severe rainfall, normally the rainfall happens. So there is a dramatic improvement in the forecast capability of India Meteorological Department since when they have started assimilating this satellite-based observation system. So these are the 4 core areas in which for the societal benefits we are operating our satellite systems. One by one, I will show you certain examples. So four or five major important areas is the food security. We have a large population, and to provide food to all citizens of India, we have to make sure that they're producing enough food every year. So most of the food is produced by agriculture practices in India. So today, for policy makers, especially for Ministry of Agriculture, we need to know that how much area is under what crop. And if some particular year, due to certain reasons, some crop deficit is there. Let us say onions is always a problem. Pulses are always, sometime a problem. Suddenly, you have seen few years back, the pulse prices shot up to 200 rupees or something like that. Because in certain regions where pulses are grown, there was not enough production. So from satellite data, we can monitor that which crop is basically there under what area. So suppose if one particular crop area has reduced because of certain reasons, then we can advise to the government that look, this year this crop is likely to be less, and then they can start planning for importing that crop from outside or make some alternate arrangement. So there is a systematic program now with the help of Ministry of Agriculture where regular information on crop acreage and how much production will happen. In fact, we are able to now estimate that production also for wheat and rice and for another 12 other major crops of India. Another important aspect is the crop condition assessment and yield modeling. You see, the condition of crop also depends on the rainfall. If sufficient rainfall is not there, then you have to depend on irrigation, and mostly still.
Please conclude, sir, please.
Yeah, I will take another 2-3 minutes and tell you that what type of applications.
Okay, sir.
So water is another important thing where we are basically using a lot of information about providing data about the water surfaces and what type of water check dams, etc. has to be made at different levels. Similarly, for environment also, large amount of information is going, that forest cover mapping, snow and glaciers, desertification studies, then disaster management I talked about, and similarly weather and climate studies. Large amount of space data is being used today. So this is one area I just wanted to show you. This is a village map in Gujarat, and then for each village, now today the village boundaries has been digitized. You can overlay the village boundary and then see that in which field फार्मर के किस केस में कौन सा फसल है, कितने दिनों तक वो फसल है और उस फसल की क्या कंडीशन है, इसको आप सैटेलाइट से मेजर कर सकते हो. और क्रॉप के जो इंश्योरेंस चल रहा है, क्रॉप इंश्योरेंस प्रोग्राम में ये डेटा का बहुत यूज है. इंश्योरेंस कंपनियां जो हैं वो अब सैटेलाइट डेटा का यूज करके इंश्योरेंस के क्लेम्स को सेटल कर रही हैं. इसी तरह से जो ग्लेशियर्स हैं वहां से कितना जो है स्नो पिघल रहा है और कितना हमारा वाटर बॉडीज में वाटर जनरेट हो रहा है, उसके ऊपर भी हम निगाह रख सकते हैं. तो काफी सारे यूज हैं स्पेस के. मैंने साइक्लोन्स के बारे में आपको बताया, फ्लड्स के बारे में आपको बताया. तो इन सब डेटा को हम अपने पोर्टल्स पर रखते हैं. हमारा एक पोर्टल है, मॉसडेक पोर्टल है, ऐसे ही भुवन पोर्टल है. अगर आप इन पोर्टल्स पर जाएंगे तो सारे इंफॉर्मेशंस को आप जो है एक जगह पर पा सकते हैं. और ये सारी इंफॉर्मेशन डिजास्टर मैनेजमेंट अथॉरिटीज और गवर्नमेंट ऑफ इंडिया के 65 मिनिस्ट्रीज के साथ शेयर की जाती है. जहां तक IRS का सवाल है, देहरादून में अगर जो स्टूडेंट्स हैं जो वहां पर बैठे हैं और इस प्रोग्राम को सुन रहे हैं, वो ट्रेनिंग प्रोग्राम हम चलाते हैं जिसमें PG डिप्लोमा प्रोग्राम है, मास्टर ऑफ टेक्नोलॉजी प्रोग्राम है, MSc प्रोग्राम है. तो आप सब लोग हमारी वेबसाइट पे जाके इस प्रोग्राम्स के बारे में जान सकते हैं. और अगर जिन स्टूडेंट्स को इसमें इंटरेस्ट है वो स्टूडेंट्स इसको ज्वाइन कर सकते हैं. हम डिस्टेंस लर्निंग प्रोग्राम भी चलाते हैं जिसमें कि लगभग हर महीने हमारा कैलेंडर है हमारी वेबसाइट पे. अगर आप लोग इस स्पेस टेक्नोलॉजी के बारे में ज़्यादा जानना चाहते हैं तो आप अपनी जगह से बैठ के भी, जैसे आज हम ये ई वेबिनार कर रहे हैं, आप लोग वेबिनार मोड में भी हमारे प्रोग्राम्स को अपने कॉलेजेस में और अपने स्टूडेंट्स तक पहुंचा सकते हैं. बस इसी के साथ मैं समाप्त करना चाहूँगा कि इसरो का एक बहुत एक्सटेंसिव प्रोग्राम है. हम जितने सैटेलाइट बनाते हैं उसको सर्विसेज को मेंटेन करने के लिए आगे की फ्यूचर प्लानिंग भी रखते हैं. तो अगले आने वाले समय में भी आप देखेंगे कि काफ़ी स्पेस एक्टिविटी रहेगी और जो सैटेलाइट डेटा आप मिल रहा है उस सैटेलाइट डेटा को हम लोग अपने कॉमन मैन तक पहुँचाने के लिए अग्रसर रहने वाले हैं. आप सभी का बहुत बहुत धन्यवाद. और अगर कुछ किसी को कुछ प्रश्न पूछना है तो मैं उसके लिए हमेशा आपका स्वागत है। थैंक यू।
Thank you, sir, for very nice and informative lecture. If there is any question from participants.
Okay, I think. Thank you very much.
हेलो अनिल जी, हेलो अनिल कुमार जी।
I think, sir, there is a problem in
Okay.
connectivity.
So I request to next speaker.
More, sir. Parveen More ji. Hello, Rakesh, sir.
Hello. Hello. I invite Dr. P.S. More from Mumbai Institute, Mumbai, to give his lecture as eminent speaker, Dr. Praveen More. Hello, Praveen S. More. Mary? Sundar Singh ji.
Yes, Parveen More is available, sir.
Yes, sir. Yes, sir.
Yes.
Yes.
Please, sir, start your.
Yeah, that screen is not able to sharing from your side. Hello.
Ji.
Please allow screen to share you.
Avnish ji.
Hello.
Avnish ji.
Surinder ji.
Sundar Singh ji.
Yes, yes.
देखो
Yes.
allow करो सर को.
Please allow my screen to share you.
Yes, you may, sir, allow. I think no problem.
Not it. Not it. Post disable participant screen. That's what the message is coming.
Oh, okay, sir. Okay, wait some minutes, sir. Yes.
Hello.
जी सर, आप शेयर करके देखिए आप.
Yes.
Yes, sir. Okay, sir.
Yes. Can you hear me?
Yes, sir. Yes.
Thank you very much. I'm very much happy to share my experience and research of my institute and my lab to everyone. Good afternoon, everyone.
Sir.
Basically, my research is based on porous nanomaterials, and this lecture is basically for the PhD and research students. I'm going to deliver a talk on physics of materials, nanotechnology for future. That is basically for agriculture people and the farmers. And now COVID-19 is also a major issue for that. And this work is the detector based technology. Hello, can you hear?
Yes, sir.
Hello.
Yes, sir. Yes, sir.
Yes.
Yes.
So I'm especially thanks to the organizing committee, all the members, and basically I'm very happy that this e-conference is in collaboration with mathematics and physics. So let's proceed for the lecture. The new generation application materials, as everyone is aware, that advanced computing, electronics, sensor treatment, energy storage, energy textiles, environment, metalworking, packaging, and pharmaceuticals, and many more applications are there, as everyone is aware. Some new material types, as let me introduce first the carbon black, silica fumes, clay, metal alloys, ceramics, and some many things which metal oxides complex are being used. As everyone is knowing that synthetic metrology or material characterization techniques are from top to down, that bulk particulate materials are broken down and into smaller and smaller particles into nanomaterials, and or from bottom to top, as the nanoparticles are built up atoms and molecules at a time. Energy is required for promoting the reactions and which involves both surface chemistry and surface physics of them, that to study the effect on it. Some nano structure materials are nanoceramic powder, nanotube, nanocomposite. As you know that nanoceramic powders consist the important segments of whole nanostructure materials, constitute more than 50% of total nanostructure materials. Nanotubes includes conductor, semiconductor, strong materials with the good thermal conductivity. Nanocomposites, generally polymer based with nano size fillers. Commercial products, as you know that nano ceramics are available commercially in the form of dry powders or liquid dispersion. Most commercially important nano ceramic materials are silicon oxide, titanium oxide, aluminum oxide, iron oxide, zinc oxide, and many more. Silica and iron oxides nanoparticles have commercial histories spinning half and counter or more. Increasing importance are mixed oxide titanate, indium titanium oxide, antimony tin oxide, barium titanate, and many other compositions we can take. What now? Which technology for these materials we can use? That CMP, magnetic fluid seals, transparent function coating, magnetic recording tape, hard disks, and JMR hides, power transformation core, sunscreen, MRI contrast gains, biomagnetic separations, sports equipment, and many more applications we do. As aware that chemical mechanical polishing is very important for new technology, that planarization of metals and dielectric layers on semiconductor to study the surface effect of that particular semiconductor vapors. Typically itself use silica, alumina, and other material. Magnetic fluids sealing is also very important. Dispersion of supramagnetic iron oxides. Currently, we used to use in loudspeaker, hard disk device, vacuum feed tools, MEMS, names, and other bio applications. Transparent conducting coating is also important. Indium tin oxide we use basically in CRTs, photographic film, FDP electrodes, touch screens, and the film produced by vapor depositions or nanoparticle technology. Silicon nanocrystals memory, that also we are aware that flash memory alternative, silicon nanocrystals or quantum dots replace continuous silicon film. Nanotubes based memories are in the new era. Near-term nanotube ribbons, long-term single nanotubes or nanowires, ultra-high density, and the things are there. Evolution of this new technology from vacuum to nanotechnology, as everyone is aware that from 1900 to 2050, this new technology is being developed. I mean, new technology is basically for miniaturize the materials, miniaturize the technique, and to make the device which is in the small size, that is now focused. I will just introduce the size dependent property. As everyone is knowing about the metals, we used to reduce to nano size from 100 micron to 1 nanometer size, or atoms on molecular level. Dimensions of the materials, as you know, that the three-dimensional, two-dimensional, one-dimensional, and zero-dimensional materials we used to use for the new technology. Nanoscale has a different properties than bulk, as everyone is aware that the nanomaterials, when it converts to nano size, its appearance of colors and properties get changed. Nanometals have particular optical properties due to the silicon confinement. Metal nanoparticles have colors that are depends on the size and surrounding. This allows the solution of nanoparticles for sensor. Size dependent property, as I'll tell you, that the nanoscale size can lead to different physical and chemical properties. They basically optical properties, band gap, melting point, surface reactivity. Even when such nanoparticles are concentrated into microscale solid, new properties of bulk materials are possible. For example, enhanced plasticity. Making the connection between the nanomaterials and biology, biological extract or biological particles, that inorganic nanoparticles are scaffold or immobilized with amino acid, that is basically we used to use as a capping agent, that is protein and enzymes, drugs, and biological method for synthesis of inorganic nanoparticles. Hello. Here the plant metabolites plays an important role to reduce the metal ions. Benefit of nanotechnology: there are number of products available there with this, that sunscreen as an example. Many of them coated contained with the nanoparticles of zinc oxide and titanium oxide. Nanotechnology offers wide range opportunities in agriculture, processing, product, and nutrition. Many examples have been shown over here. That is, in agriculture, new pesticides, genetic engineering, identity preservation, sensors to measure the soil conditions, preservative, and even in processing, that microencapsulation, dilation agent, nano emulsion, anti-caking, and sanitization of the equipment. Even in products, that UV protection, antimicrobial activities which you use, high barrier plasticities, and other. What is the things which we have developed in our lab, that I will let you know, that the home built optical waveguide based characterization system which we have developed in our lab. What we do is all the nanoparticles which are developed in the lab, which we used to coat on the waveguide as the embedding material. And here which we have used a laser source with a different wavelength. That is here that lenses which we use to polarize the beam on a particular waveguide, that we have connected to the photo detectors. Basically, this application which we use for the gas sensors and soil element analysis, and the another sensors applications. Here are the different light sources are there, basically laser sources with the different wavelengths, that which we have connected to the polarizer or lenses through the optical cable. And the waveguide which we made with the optical cable, that which we have embedded with the nanomaterials with the particular selecting material, and those when we connect, that we use to analyze its intensity and the appearance on the particular system, which we record the data on the PC. Here are the mechanism which we have already introduced in the number of research papers which we have published from our lab. Here what we do is the nanopores and micropores which we have developed. All the nano size material which we have embedded on this particular pore. Here the gas which we have to detect, basically which we used to introduce in the system, and whatever the change in potential which we used to record, and through which we can see that how much is the sensitivity taken place. Here this diagram is basically this is the net which we have coated with the nanomaterials. Here I have shown here a zinc nanomaterial, or which we can say is a nanowire, that we have exposed to the gas, that also give you the change in sensitivity for a particular sensor. Here are the IECEM or TEM images which we have been seeing, that all the particles which we have coated on the particular mesh or a particular slides. There we can see that all the nanoparticles, which is basically ranging from micron to nano size. That size is up to 1 nanometer, which we have achieved. That is basically this coating is of metal oxide with the biological extract. Nanoparticle synthesis, as you aware that the colloidal metals and colloidal semiconductor particles are made in the solution of a precursor chemical compound, and basically goes with different ways to coat on the particular surface. Here which we have seen that the gold nanoparticles which we have suspended and achieved the 50 nanometer of size, that we have coated on the porous aluminum. Here which we have shown that the porous aluminum and the porous silicon. Here the pore size is basically from 100 nanometer to say 10 to 20 nanometers which we have achieved. And here in the porous aluminum also, which we have achieved the size of nanometers, and that we have coated with the sensing materials, that which is basically used for different applications for gas sensor as well as soil element detection system. And whatever the particles which we have coated on the pores, that surface which we can see over here, that platinum nanoparticles which are suspending on the porous surface, that we can see that image, that how that surface is modified. Here I can show that the mechanism with the surface, that IECEM microphotograph of platinum coated on the porous aluminum surface, and the picture which you have seen, that the nanoparticles of platinum which being covered porous surface of aluminum. And this
Please conclude, Dr. More.
Hello.
Conclude, sir, please.
Yes, okay. So the gas absorption disruption taken place on the surface. This is the characterization system which we have in our lab. The data which we have achieved, that the acetone and sensitivity which we have seen up to the 900 and up minimum to 40 degrees centigrade and maximum to 80 degrees centigrade. Platinum modified porous aluminum system which we have achieved for the different gas sensors like methanol, acetone at very low temperature from 40 degree to 100 degree. Other gases also which we have detected from carbon dioxide, also 40 degrees centigrade, which we can able to detect, and up to 80 degrees centigrade. Palladium nanoparticles which we have coated on the porous aluminum surface, that also which we can achieve at very low temperature we can detect acetone, carbon dioxide, carbon monoxide also. This is the biologically extracted samples which we have tested for plant detections, that how much is the carotene and xanthophyll contents in the plant, that which we also senses with that particular surface. This is the general mechanism which we can show on the surface. These are the surface which we have seen. Here the XRD data from which we can come to know that what are the particles which are present. Which we have seen that which is present in tin oxide, copper is converted into copper and cuprous oxide. This is the XPS data which we can see that all the things which we have seen in the XRD, which can see that the copper is converted into cuprous and copper oxide. These are the XPS data, and through which we can come to know that at sinking temperature, 800 degree sinking temperature material, which we can see that the maximum sensitivity which we can get to the number of gases. This is also the XPS data. From conclusion, I could tell that the nanoscale material engineering will have increasing importance to the number of sectors, including biotechnology, electronic, and industrial products. Nano-size ceramic powder market growth is every year in 10% in the year. SWNT are likely to see exciting applications such as microscope tips, FEM, SEM tips, and all. Nanocomposites have found a number of applications such as automotive and other packaging technology. Thank you. With this,
thank you, Dr. More.
Yeah, thank you, sir.
Thank you, sir, for very nice and informative lecture.
Any questions, sir?
Any question from the participant? If okay, sir, thank you.
Sir, I have one question.
Yes.
Ask, please.
Hello.
Yes, please.
Sir, at one point you have said that there are some particles of 1 dimension and 0 dimension. So in what sense they are? Any example?
In size. When you convert from micron to nano size, we can achieve to 0 dimension size, means as less as possible. That is basically the quantum things which we use, quantum applications.
Okay.
Hello.
Okay, sir.
Yes, sir. Thank you, sir.
Thank you, Dr. Saab.
Now
I invite convener of the conference, Dr. Rakesh Kumar, from Board of Thanks.
I think
Dr. Rakesh Kumar.
Yes, I will. Thank you, Dr. Anil Kumarji. I think the vote of thanks we will give after the presentation, so that we can make the time. I request to Dr. Mukul Kishore and Dr. Sanjeev Rajan, please come for presentation. I think it will be good. Hello.
Okay.
Are you listening me? Dr.
Yes,
Anil?
yes.
Okay.
Yes.
Dr. Mukul Kishore ji. Hello. Dr. Mukul Kishore ji. I think he is not in picture. Dr. Sanjeev Rajan.
No, Mukul Kishore ji is here.
Then where? Please talk to him.
Okay.
Hello.
Dr. Mukulji, you are hearing me? Dr. Sanjeev Rajan ji?
I think we will start in between. He will join. So please, Dr. Sundar Singh ji, please share the screen of first participant.
Okay, sir.
Okay.
Call him. Who is the presenter?
Our first participant is Dr. J.K. Singh.
Jitendra Kumar Singh, can you hear me?
Yes,
please
yes.
enable enable him first.
Yes, I can hear you, sir.
Yes,
Okay.
please start.
Let you start, please.
You have
Okay.
5 minutes for
Okay.
presentation.
Okay.
Continue, Jackie Singh ji. Continue.
Okay, sir, I am continuing. Just 1 minute. So, good afternoon to all. Myself, am I audible, sir? Am I audible?
Yes, yes.
So, good afternoon to all. Myself, Dr. Jitendra Kumar Singh, and my title of presentation is Hall and Iron Slip Effect on MSD, Free Convective Flow of a Viscoelastic Fluid through a porous regime in an inclined channel with moving magnetic field. So, I subdivided, sorry, there is some issue, sir. It is not moving.
Yes,
Hello.
yes, yes.
अरे आप सुंदर सिंह जी आगे बढ़ाते रहिए.
Yes.
So if you give a screen share option, sir, I will share the screen.
Okay, sir. Okay, I request to our host Avnish Chauhan ji, make the host of Mr. Jitendra Kumar Singh. Hello.
Sir,
Avnish
please.
Mr. Avnish Kumar is available here. Avnish Chauhan ji.
सुंदर सिंह जी सर बोले तभी नेक्स्ट स्क्रीन कर दीजिए ना आप, जिससे कि जल्दी हो जाए.
He is saying he is saying Mr. J.K. Singh saying to make the co-host.
Sir, it would be better if I will share the screen.
Okay, sir. I call.
Okay. Now I can do.
Yes,
okay, sir. Thank you very much, sir. Okay. So I subdivided my presentation into 6 sections. First section is the physical model of the problem. Second section is the mathematical model of the problem. Third is the solution of the problem. Then numerical results, conclusion, and final is the references. So this is the schematic diagram of the problem. I consider the flow of viscoelastic fluid within this parallel plate channel, which is inclined through an angle gamma. And we have considered the flow is permitted by a strong magnetic field B naught, so that the Hall and iron slip current can be generated. And right inclined plate is supposed to be oscillating with the velocity u naught plus 1 plus epsilon cos omega dash t dash, and temperature of the left wall is T1, while the temperature of the right wall is it is also oscillating T2 plus epsilon, T2 minus T1 cos omega t dash. And same way we have the concentration. So this is the physical model of the problem. The flow governing equations, these equations consist of the momentum equation. So momentum equation along x direction is given by equation number 1, while the momentum equation along y direction is given by equation number 2. And here I also suppose that the magnetic field is also moving. So that K1 term is there. So K1 is 1 when magnetic field is moving with the equal velocity as that of the right wall. And K1 is 0 means our magnetic field is stationary. The another governing equation is the energy equation with the heat source term I have taken. And the next governing equation is the concentration equation or mass diffusion equation. Equation 5 represents the boundary conditions, the conditions to be satisfied at the boundary walls. And to convert our problem to a similar problem, I use the non-dimensional transformation, which is given by equation number 6. On using these non-dimensional transformations, our flow governing equations, that is the momentum equation, energy equation, and concentration equation, assumes the form of equation 17, 18, and 19. And same way, our boundary condition assumes the form of equation 10. So now for solving the equation, I use the method of separation of variable, and I assume the velocity, temperature, and concentration in the form of equation 11, 12, and 13. Now using the using equations 11, 12, and 13, the partial differential equation reduces to the ordinary differential equations. So which are given from equation number 14 to 22, and which are solved analytically with the help of the boundary condition 23, and the solution for velocity is given by equation 24, whereas the solution for temperature and concentration are given by equation number 25 and 26. I have also calculated the skin friction coefficient at both the inclined surfaces, whereas rate of heat and mass transfer also I calculated at the left and right surfaces of the channel. And now to analyze the behavior, flow behavior, I've done the numerical computation, and numerical results are presented in the form of graphs. So the first graph is for the effect of Hall current parameter on the flow. So we are looking here that the velocity in both the main flow direction and perpendicular to main flow direction, both are rising the Hall current. This is due to the fact that Hall current is induced due to spiraling of the fluid particles about the magnetic lines of force. So this is the reason why it is enhancing the fluid flow. Here we are looking the iron slip parameter. It is enhancing the primary flow, whereas it is reducing the secondary flows. Rotation shows the effect that it is inducing the reducing the primary flow, whereas it is inducing the secondary flow, which is the actual nature of the rotation, because it creates the Coriolis force. Here the magnetic fold. So we know that magnetic fold suppresses the fluid flow due to the presence of Lorentz force. In our case also we are looking the similar behavior. This is the behavior of the porosity parameter. So permeability also shows the same effect as similar as the magnetic field, because it is also produces the drag force. So that's why the velocity is reducing. And here this is the velocity distribution for the angle of inclination. So as we rise the angle of inclination, buoyancy force reduces. As a result, the fluid velocity also reduces. Now this is the effect of viscoelastic parameter. So viscoelastic parameter tends to reduce the fluid flow, and that's the oscillation. Oscillation is rising the flow we have here. Now this is the effect of the moving magnetic field. So we are observing here the moving magnetic field reduces the fluid velocity. Induces the fluid velocity. This is the temperature profile. So on rising the angle of acceleration. Okay, sir. Temperature is rising. Similar way, concentration is also rising on rising the oscillations. So these are the significant findings which I have already told during the graphs. These are the references. Thank you. If you have any questions, you may ask me.
Okay, thank you. Or any question from the audience? No, I think there is no question. So call second participants presenter. Okay. Dr. Sundar Singh.
Yes, our next participant is Vijayata Pathania. Is available here? Can you hear?
Hello. Vijayata Pathania.
Can you hear me?
Raise hand.
Achha, unmute. Ask to unmute. Unmute yours. Unmute the Vijayata Pathania.
Hello.
Yes.
Good afternoon, sir.
Okay. Please.
Hello, ma'am.
Sir, I am audible?
Yes. Start your video.
Yes, sir. Good afternoon to all of you. I am Dr. Vijayata Pathania from Himachal Pradesh University, Regional Center, Dharamshala. The topic of my presentation is circular crystal waves.
Hello. Listen to ma'am.
Yes, sir.
Do you want to share your screen yourself? Yeah, I allow us to share?
Yes, I want to share my screen, sir.
Yourself? Yes, sir,
Yes,
you may
sir.
go. You may go.
Okay, sir.
You may
Okay.
share. And the audio and the video is also
No, there is no need of
on.
Sir, I am audible now.
Yes, yes.
My screen is
Yes, yes, showing.
okay.
You may go.
Okay. Good afternoon to all of you. I'm Dr. Vijayata Pathania from Himachal Pradesh University, Regional Center Dharamshala. The topic of my presentation is circular crested waves in thermoelastic plate with voids in contact with liquid layers. The main points of my discussion are formulation of the problem, basic governing equations, non-dimensional basic equations, equations in terms of potential functions, solution of the problem, boundary conditions, secular equations, conclusions, and at last bibliography. The formulation of my problem is, here we consider an infinite homogeneous isotropic thermally conducting elastic plate with voids of thickness 2D initially at temperature T0. The plate is bordered both on top and bottom with infinitely large homogeneous inviscid liquid layers of thickness H. The plate is axisymmetric with respect to the z-axis as axis of symmetry. The origin of the coordinate system is taken at any point in middle surface of the plate and z-axis normal to it along the thickness as shown in the figure. The surfaces z equal to plus d and minus d is subjected to different boundary conditions. Here we take RZ plane as the plane of incident. The basic governing equations in the absence of body forces, equilibrated forces, and heat sources are given by equations 1a, 1b, 1c, 1d, 1d, 1e, and 1f. Here, the equations 1a and 1b shows the equations of motion. Equation 1c is the equation of void, and the equation 1d represent the heat conduction equation. And similarly, for the liquid layers, the equations of motion are given by equation 1a and 1f. Here we have taken I equal to 1 is for the bottom liquid layer and I is equal to 2 is for the top liquid layer. Now we define the non-dimensional quantities by equation 2, and using these non-dimensional quantities in equations of motion, equations of void, and heat conduction equation, we get equations 3a, 3b, 3c, 3d, 3e, and 3f, where these parameters are used in equations 3e to 3f. Now, in equation 4a and 4b, we define the Helmholtz decomposition theorem, in which the displacements are given by the potential functions g and psi. And using these equations 4a and 4b in equations 3a to 3f lead to the equations 5a to 5e. Now we take the solution in the form of equation 6a and 6b, where J0 is the Bessel function of order 0 and equation 6b, J1 is the Bessel function of order 1. Using these equations in equations 5a to 5e, we get the potential functions in the form of 7a, 7b, 7c, 7d, and 7e and 7f, and the roots are given by equations 8a and 8b. Now the boundary conditions at the solid liquid interfaces, that is at z equal to d and z equal to minus d, are given by the first boundary condition is the tangential component of stress tensor should be equal to the pressure of the liquid, and which is given by sigma zz is equal to sigma zzl, and the normal component of the stress and the normal displacement of the solid plate should be equal to the liquid part, and the void boundary condition is given by fourth point, and the thermal boundary condition is given by the fifth point, where H is the heat transfer coefficient. Using these boundary conditions in equation 9, we get the 10 linear homogeneous equations in 10 unknowns. These equations would have non-trivial solution if and only if the determinant of their coefficients is equal to 0. And after some algebraic manipulation of the determinant, this leads to the secular equation 10. This secular equation 10 gives the idea about the phase velocity, attenuation coefficient, etc. Now for the thermally insulated case, that is when H approaches to 0, equation 10 reduces to equation 11.
Please conclude, ma'am.
For the isothermal case, this reduces to equation 12. Now the conclusions are, it is observed that motion of the purely transverse wave get decoupled from the rest of the motion and remain unaltered due to the thermomechanical coupling and void effects. The governing equation which are left would correspond to the coupled longitudinal, shear vertical, thermal, and void motion. Secular equation give the complete information about the wave, such as to find the phase velocity, attenuation coefficients, etc. Present thesis is useful in the task of unearthing worthful things such as oil deposit beneath the earth's surface rather than the drilling randomly, which is time consuming and not economic process. These are the some references which I have used to prepare this paper. Thank you.
Okay, thanks. Any
Yes, any
question?
question?
Hello.
Sir,
Nice.
any questions?
No, I think there is no question.
Okay, thank
Thanks
you.
for presentation. Please,
Thank you.
Sundar Singh ji.
Dr. Ashwini Kumar GP.
Yes,
Ashwini
Dr.
Kumar
Mukul
GP.
Kishore ji with us, I think. Dr. Mukul Kishore ji. Dr. Mukul Kishore ji.
Yes, speaking.
Yeah. Yes, sir. Now you can take the session, so you can call.
You can continue with the mathematics papers.
Okay.
I will join you when physics papers start.
Okay, okay, thank you. So, call next participant.
Next participant is Ashwini Kumar GP is available. Unmute your Mr. Ashwini Kumar GP. Dr. Ashwini Kumar GP, unmute yourself.
Hello.
Yes.
Please allow me to share my screen.
Hello.
Okay. Good afternoon, everyone.
Very good afternoon. Continue.
Myself, Ashwini, I am working as a professor in Department of Mathematics, Vijayanagar Sri Krishnadevara University, Ballari. The topic of today's presentation is three-dimensional MFT of hybrid fluid past a slendering surface with a slip effect. In this study, we have taken a hybrid. Hello?
Dr. Ashwini Kumar
Hello?
GP.
Yes, yes. Now your screen is okay.
Continue.
Okay. Here we have
there, I think there is connectivity problem with.
So you share the screens all the participants. Please, Sundar Singh ji.
Yes, yes.
Hello. Hello.
Yes, yes. Continue, Dr. Ashwin Kumar.
To connectivity have problem. Introduction, mathematical formulation, and numerical solution. Result is references. As I have told you, this one we have considered an hybrid nanofluid which is passing through a stretching surface with a non-uniform thickness. In the presence of the slip parameter we have considered is temperature slip. So the nanofluid is a composite mixture of this aluminum alloy nanoparticle, it is AA7072 and
सुंदर सिंह जी आप ही शेयर करिए स्क्रीन को.
Okay, son. I think there is a problem. We have to call the next. Huh?
Yes.
This is a physical of the problem.
Yes.
Taken. The fluid is flowing along XY direction and the magnetic field is applied like this. And here we can see that the geometry, the stretching sheet it is not with some same thickness. It is a variable thickness case. And here the parameter this is the velocity along y x direction and velocity along y direction. We have considered this
I think, sir, we have to next call the next participant.
Okay.
Dr. Alfred Yusuf Sheikh is available. Hello, Dr. Alfred. I think he is not available.
So go to next presentation.
Go to next, Mr. Deepak Kapil. Deepak Kapil, unmute yourself.
Yes, sir. Hello. Are you hear me?
Yes. Please start.
So I have my PPT on screen, sir.
Okay. स्क्रीन पे पीपीटी डालिए आप सुंदर सिंह जी.
Yes.
आप शेयर कर दीजिए सभी.
Okay.
दीपक कपिल. Yes.
Yes, Mr. Deepak Kapil, you may continue.
Yes, sir. Good afternoon, all of you. Myself is Deepak Kapil, and I am presenting my research paper entitled Effect of Magnetic Field on Thermal Impermanence of Viscoelastic Ravelin Erection Nanofluid Layer. Abstract is that the numerical and graphical study on magnetic field impression on thermal impermanence of viscoelastic Ravelin erection nanofluid layer has been carried out in this paper. The influence of physical parameter as Lewis number, modified diffusivity ratio number, nanoparticle Rayleigh number, and magnetic field studied analytically on the stationary deportation. A number of theorems established which satisfies the condition for stability or instability. The Lewis number, modified diffusivity ratio number, nanoparticle Rayleigh number are found to have destabilizing influence, and magnetic field has stabilizing influence on the stationary convection of fluid layer. The keywords of the paper are nanofluid, Ravelin erection, viscoelastic fluid, normal Mordnet technique, oscillatory convection, Rayleigh number, Lewis number, modified diffusivity ratio number, magnetic field. we have introduced the governing equation of this, the viscoelastic Ravelin-Erickson nanofluid number del QD is equal to 0, which is given by equation number 1 and equation number 2. And we put the value of rho, that is phi rho p plus 1 minus phi. Put in equation number 2, we get equation number 3 and equation number 4. The energy equation in nanofluid is given by equation number 5. The Maxwell equation is given by equation number 6 and equation number 7. Where QD represent the velocity vector, P represent the hydrostatic pressure, delta and delta dash are the viscosity and kinematic viscosity, elasticity respectively, and G be the acceleration due to gravity. Mu m is the fluid magnetic permeability and H is the magnetic field. Where rho p and rho f are the densities of nanoparticles and base fluids. Alpha is the coefficient of thermal expansion, dB and dt are Brownian diffusion coefficient and thermoparatic diffusion coefficient of nanoparticles. We have the equation in non-dimensional form, which is the part of second, is given by the equations number 8, 9, 10, 11, 12, and 13. Now we have the equation. We have the equation solved by the perturbation method, that is known as the perturbation solutions. The given equations are for equation number 14 to equation number 19. Since just a measure of basic static pressure gradient, so it is not involved in this and subsequent equation. Now equation number 15 multiplied with curl dot curl, we get equation number 20. Now we use normal mode analysis for the analyzing the result. We have the equation number 21, 22, 23, and 24 in the normal mode analysis. Now we start linear stability analysis. We use the function W as W0 sin pi z, T as T0 sin pi z, phi as phi 0 sin pi z as given in equation number 25. We have eigen equations given by RA, equation number 26, sorry. We have RA which is equal to delta 1 plus I omega delta 2 given in equation number 27. Real part is given by delta 1, that is equation number 28. Imaginary part is given by delta 2, that is equation number 29. Now we discuss on the stationary convection. When the stability sets in the stationary convection, the marginal state will be characterized by equation number 27 reduces as equation number 30 and equation number 31. Now we introduce the result. We introduce some important theorems. Theorem first, the system is stable under the given condition shown in the slide. Theorem 2, theorem 3, and theorem 4. Now for result, we get some graphs on the screen. We have the graph on the screens, and on the base of graph, we have some result, which is given. So next slides, please, sir.
Next. Please conclude.
Results, sir. On results, sir.
Results नीचे ले लीजिए. Yes. इससे
ऊपर वाली slide, sir.
थोड़ी. Yes. Conclude.
Yes, sir. The thermal instability of viscoelastic Ravelin-Erickson nanofluid layer heated from below under magnetic field is investigated by using linear instability analysis. The main conclusions from the analysis of this paper are as follow. For the stationary convection, magnetic field has stabilizing effect on the system. Lewis number, modified diffusivity ratio, and nanoparticle Rayleigh number have destabilizing effect on the stationary convection. Whenever magnetic field has the stabilized effect on the stationary convection. Thank you, sir.
Okay, thank you.
Any questions, sir?
Any question from the participants? No, there is no question, I think. So please.
Thank you, sir. Thank you very much.
Dr. Dheeraj Kumar Joshi is available. Dheeraj Kumar Joshi.
Yes. unmute Dheeraj Kumar Joshi.
Hello, I'm audible. Hello.
Yes.
Yeah, good afternoon, everyone.
Yes, good afternoon.
Myself, Dr. Dheeraj Kumar Joshi. Please, sir, allow
Share
me
the
to.
screen.
Yeah. Please allow me, sir, if possible.
Okay, you may. You can.
Okay, sir. Thank you. Yeah. Screen is visible to everyone. Hello.
Yes. Now it
Yeah.
is visible.
Myself, Dr. Dheeraj Kumar Joshi from DIT Institute, Dehradun. Actually, my topic is distance and similarity measure for probabilistic Hagitan fuzzy set and its applications into stock selection problem. These are the contents of my topic. Introduction, we will discuss what are the fuzzy set. Thereafter, we will introduce probabilistic Hagitan fuzzy set and distance and similarity measure and some numerical examples. Thereafter, results and conclusion. So first of all, this one. First of all, we will discuss what is multi-criteria decision making. Actually, multi-criteria decision making is a process of finding the best solution from a set of given alternatives. They may be conflicting in nature, and if there are more than one decision maker is there, this is called group decision making. Next one, we have developed a Topsis method for Hagitan probabilistic fuzzy set. The Topsis method is a classical MCDM method, which is based on the concept that chosen alternative is closest from positive ideal solution and farthest from negative ideal solution. Now, what is probabilistic Hagitan fuzzy set? Probabilistic Hagitan fuzzy set is in the order pair of this form. Here, Hagitan fuzzy set is included by probability, associated by probability. This one is a set of element. And what is the condition that sum of all probability is equal to 1? It may be less than or equal to 1. We have developed distance measure for probabilistic Hagitan fuzzy set, and it must be possess following properties. These are the properties of distance measure or metric space. First property is that distance must be lies between 0 and 1, less than equal to 1 and greater than equal to 0. Second condition is that distance between H1 S2 is equal to distance between S2 and S1. It must be symmetric. Second one, if two sets are equal, then distance between them must be equal to 0. Distance between any set with its complement is equal to 0. And this distance measure also satisfies the property of triangular inequality. Yeah, next one. We have developed a distance measure, a series of distance and similarity measure for probabilistic Hagitan fuzzy set. These are the some review. First one, we have developed normalized distance Hamming distance, which is defined by equation number 14. We have developed this one. Similarly, we have also extended this for Euclidean distance. For normalized, generalized Hamming distance, Hamming-Hausdorff distance. These are the combination of Hamming Euclidean, and it may be Hamming-Hausdorff, it may be Euclidean-Hausdorff, and last one is normalized Hamming distance. In similar manner, similarity measures are also defined for probabilistic Hagitan fuzzy set. This similarity measure is equal to 1 minus distance measure. So we have developed normalized Hamming similarity measure, which is equal to 1 minus normalized distance measure. Similarly, second equation number 23. Now, a real case study has been taken to understand the develop distance and similarity measure. In this case, in this study, we have taken a Topsis method to apply to rank the organizations. First organization is A1, State Bank of India. Second one is Infotech. There are some 7 alternatives are there. These alternatives are ranked by using proposed method by using these 6 criteria. These are the criteria: earning per share, it may be face value, book value, and this data is taken from this site www.moneycontrol.com from the date 2nd Jan to 9th Jan. This is the average value which are taken from the moneycontrol.com. Here, alternative 1 for alternative 1 under the criteria 1, value is 13.15. This is your actual numerical values. First of all, we will want to change this data into fuzzy data.
Please conclude.
Okay. We have developed this step to find the hesitant fuzzy decision matrix. Thereafter, by using Topsis method, we have ranked the 7 organizations, and our best organization is A5 and worst organization is A3 by using Topsis method. And one sensitivity analysis is also done by the change of parameter, what is the effect on best and worst. But in our case, for lambda equal to up to lambda equal to 6, your best alternative is A5 and worst alternative is again A3. Thank you.
Okay,
yes.
thank
Any
you.
questions?
Is there any question from the audience? So you have presented very good. Okay. Next.
Next is our next participant is our Dr. Kishore Bankhade. Dr. Kishore Bankhade, unmute yourself.
Hello, I am audible,
Yes.
sir?
Yes, yes.
Surendra Singh, please share the screen from your side.
Okay, sir.
Okay, can I start, sir? Dr.
Start.
Kishore Wankhade, sir.
Okay.
एक second.
Okay, meantime, I will take the vote of thanks the organizers.
Okay.
Myself, Dr. Kishore Sudhakar Wankhade, Assistant Professor, Department of Mathematics, Yashwantrao Chauhan Arts and Science College, Mangalore, District, Wasim, Maharashtra, representing the Sant Gadge Baba Amravati University, Amravati. First, I express my sincere thanks to Department of Physics and Mathematics, Hindu College, Muradabad, Uttar Pradesh, for organizing a mega event through their department to provide us an excellent platform through international e-conference on emerging advances in mathematical and physical sciences. To present our research paper in this COVID-19, yes, sir, yes.
Yes, please.
Pandemic situation. Okay. Also, I express my thanks to Chairman and Principal of this institution, Dr. B.B. Singh, sir. Also, I express my sincere thanks to Convener Anil Kumar and Rakesh Kumar, sir, Organizing Secretary Sri Dilip Kumar, sir, and Surendraji Singh, sir. Now, I will start my presentation. Now, respected Chairperson for this session, Dr. Mukul Kishore, sir, and Dr. Sanjeev Rajan, sir. With the kind permission of Chair, I start my presentation. Okay. Now, the title of my research is the stability factor of cosmological model for hybrid expansion law. In this, the abstract of my paper is, we study the LRS Bianchi type cosmological model with the presence of two fluid, namely matter and dark energy in F of R gravity. The solution of field equations is obtained by using hybrid expansion law. Okay. Now the introduction contains Sir Albert Einstein invented special theory of relativity in 1905. Special relativity unifies the concept of space and time. But in special relativity, the space-time is flat, and hence this theory does not deal with gravitation. To overcome these limitations, Einstein generalized special theory of relativity and proposed a new theory in 1916 known as general theory of relativity or Einstein theory of gravitation. Einstein's theory of relativity is one of the most beautiful structure of theoretical physics, which describes the successful theory of gravitation in terms of geometry. But according to Einstein, the match principle is not subtended by general relativity. Also, singularity problem is there. To overcome these difficulties, several theories of gravitation have been proposed as alternative to Einstein's theory of general relativity. And out of these, the most important alternative theories are Siege-Ballester theory, Branch-Decay theory, Ross-Dunn theory, F of RT gravity, F of T gravity, F of R gravity. The F of R theory is gravity is the generalization of general theory of relativity. Hence, our present work is devoted to study of Bianchi type first cosmological model with the presence of two fluid, namely matter, dark energy in F of R theory of gravity and hybrid expansion law. In this paper, we consider the LRS Bianchi type first space-time ds square is equal to minus dt square plus a square dx square. Equation number 1, sir. Yeah. ds square is equal to minus dt square plus a square dx square plus b square in bracket df square plus dz square, where a and b are the metric potentials. For this Bianchi type first space-time, we consider the f of r theory as given in equation number 2. Okay. With these two equations, 1 and 2, we will get the metric tensors as given in equation number 3. Next, sir. Next. Okay. Now the field equations of this LRS Bianchi type model with f of r theory relativity are given in next, sir. Sir, please next. Okay. Are given in equation numbers 8, 9, and 10. Okay. These are the set of 3 linearly independent differential equations. Now we have to solve these differential equations. For that, we consider the hybrid expansion law. A is equal to t to the power alpha e to the power beta t and the relation between metric potential A and B. With these, we have the physical properties of this model. That means the Bianchi type spacetimes and f of r theory of gravitation. The solution, physical properties, we find out here as given in equation number 13, the Ricci scalar capital R. And in equation number 14, the function of Ricci scalar f of R as well as energy density of holographic dark energy, then isotropic pressure of holographic dark energy and stability factor of holographic dark energy. Okay. Then we discuss about the next, sir, geometric parameters. After solving these equations, we will get these equations, very lengthy equations, equations 16, 17, 18, 19. Now the next part of our research paper is the geometrical parameters. While solving these above equations, we have few geometrical parameters as given in equation 20, 21, 22, 23, and 24. We mention as equation 22 as a special volume capital V, 23, 22 as the mean scalar factor A, 22 mean Hubble parameter capital H. Next equation is expansion scalar theta, then deceleration parameter Q, and shear scalar sigma square. These are the geometrical parameters. Now I conclude my paper. In this paper, I study the Bianchi type spacetimes with the f of r theory of gravitation. And it is observed that the energy density of matter and holographic dark energy are always positive and decreasing function of time. At the initial at which the universe starts to accelerate, the universe has infinitely large energy density. But with the expansion, it declines, and at very large, it is a null. Also, the most important conclusion of this research article is it is observed that from initial to infinite expansion of the universe, the stability factor having a range nu s greater than 0, hence the universe is stable. And that concludes my research paper. I am very much thankful to organizers and the chairpersons to allow me to present my research paper in very good platform provided by the International E-Conference, Hindu College, Murabad. Thank you very much, sir. Thank you, sir. Any question from our side, sir?
I think there is no question.
Okay. Thank you, Sanju sir and Mukul sir, for giving me permission to present my paper as a chairperson. Once again, I thank you, the organizer and the Hindu College, Muradabad. Thank you, sir.
Okay.
Yes. Yes, thank you. Our next participant to present is G. Narendra. G. Narendra, unmute yourself.
Yes.
G. Narendra.
Unmute.
Yes, sir. Sir.
Okay.
Yes.
Sir. Good afternoon to all.
Okay.
Very good
Myself, G. Narendra, Assistant Professor of Mathematics, CVR College of Engineering, Hyderabad, and also a part-time research scholar in JNTU, Hyderabad. Now, today my presentation title is, sir, can you share my screen?
Yes. Just a minute.
Sir?
Yes, you can speak. Proceed.
Continue.
Yes, sir. So this is the title of my research article, that is non-uniform heat source and sink and activation energy effects on micropolar fluid in the presence of inclined magnetic field and thermal radiation. Okay. Sir, can you scroll down, sir? Next. Sir, next page, sir.
Next page.
Next. Okay, sir. Okay, sir. Stop, sir.
Mathematical modeling. Yes.
Yeah. The main objective of this paper is, first I want to review the paper of Mohammed, the research article, the author Mohammed, and I reproduced the results with my code, and the results are my results and the previous results are compared. Then I conclude that my method is working very effectively. Then I extended the paper by adding additional effects. Additional effects are magnetic inclined field, Sort and Dofer number, and activation energy on the two-dimensional hydromagnetic mixed convective heat and mass transfer flow over a stretching sheet in Darcian porous medium with the thermal radiation. Okay. Now, sir, can you show that the geometry, sir?
Oh, okay.
Geometry, sir. Above, sir. Next. No, sir.
Next.
Back, sir. Back. Next, sir. Back, sir. Next. Back, sir. Next, sir. Next. No,
previous or after? Next.
So previous one, sir. I think page 2, sir.
Page 2. Okay. This one.
Yes, sir. Yes, sir. This is the geometry of my problem. Here I am taking x-axis means stretching sheet is along the x-axis and y-axis is perpendicular to the stretching sheet. The flow is the fluid flow is moving along the x-axis and y-axis is perpendicular to the fluid flow. And here B naught is a magnetic field effect on fluid along the stretching sheet. That is a magnetic boundary layer I am considering. As we are moving away from the stretching sheet, then velocity is become stable. That is free surface we are getting. Okay. Now these are next the governing equations of fluid. Yes, sir. The governing equations of fluid flow problems are: first one is equation of continuity. Second one is equation of momentum, equation 2. Third one is the equation of angular momentum. Fourth one is the equation of heat transfer. Next, fourth one, equation 5 is represented equation of mass transfer. And the equation 6 represent the corresponding boundary conditions. Okay. Generally, to solve equations 2 to 6, it is very difficult because these are involved so many physical quantities with different dimensions. So that's why it is very difficult to solve directly. For that, I am using, sir, next, sir. For that, I am using means to reduce the physical quantities. To reduce the physical quantities, that is dimensionless form, I am using the similarity transformations. The main aim of the similarity transformation is to reduce the number of physical quantities and make them into dimensionless form. So with the help of equation 7, that is similarity transformations, now reducing the governing flow equations into this form, sir. That is the ordinary differential equation form 8, 9, 10, 11, sir. So now okay. 8, 9, 11, 8 to 11. Now these are non-linear ordinary differential equations, moreover coupled equations, and equation 12 are the corresponding boundary conditions we are getting. Now equation 13 is the quantities, physical quantities involved in that. Now generally next equation 14, 15 are these are Nusselt number and Sherwood number, sir. Now generally to solve the ordinary differential equations 8, 9, 10, 11, they are highly non-linear and coupled. So there is no analytical solution. Therefore, we have to go for numerical method only. So for that, here I am using shooting technique along with Adams-Moulton fourth order method. So for that, I am writing the given non-linear coupled differential equations. That is boundary value problem is given. Now I am writing into a ordinary first order ordinary differential equations. First order ordinary differential equations. That is equation 16, sir. So total 9 equations I am getting. These are first order non-linear differential, first order differential equations. But to solve these first order differential equations, we need all initial conditions. But there are few initial conditions are missing. Few initial conditions are missing. The few initial conditions, the missing initial conditions are obtained by shooting technique. And those obtained missing conditions are improved by Newton's method. So after getting all the initial conditions, then it become a completely initial value problem. Then using Adams-Moulton fourth order method, I solved this problem, sir. Then results and discussion. See, for the validity of our Fortran code, I reproduce the results of skin friction coefficient and Nusselt number. I compared with the previous published results. That is skin friction coefficient is a table 1 and Nusselt number 1 is a table 2. Sir.
Please conclude.
Yeah, yes, sir. Sir, next, sir. Next, sir. Graphs, sir. Graphs. Sir. So these are the sir. Yes, sir. Okay. These are the results. See, their figure 2 is a impact of material parameter K and magnetic parameter. See here. See that as we increasing magnetic parameter, the velocity profile is decreasing. Whereas as we is increasing material parameter, the velocity profile is reverse opposite is there. So increasing we are getting, sir. So similarly, all the Sir, they go for conclude, sir. Then.
Yes, yes, please.
The last page, sir. Sir, there are so many graphs are there. Means so many impact different parameters graphs are there, sir.
ठीक है.
So go for
आगे
last
बढ़िए.
page, sir.
Yes, yes. आगे बढ़िए जी. बताइए.
The last page, sir. Final page conclude, sir. Then.
Okay, okay.
These are impact of different parameters, sir. Yes, yes, sir. Yes. Yeah. Yes, finally, see, the following conclusions have been drawn from the numerical results, sir. This is the concentration profile declines by escalation of the fitted rate of constant n, the chemical reaction rate sigma, and the temperature differences parameter del, sir. Then a higher concentration is observed on increasing Dofer number, also decreasing of DF, decreasing decreasing of DF number, sir. Next,
Okay, आगे बढ़िए. जी.
The inverse Dorsey number and magnetic field, sir. The angular velocity is decreases with escalation of m naught slip condition and material parameter k. The inverse Dorsey number and the magnetic field m. In the presence of differently oriented magnetic field, the velocity decreases, but the temperature and concentration is increases. The rate of mass transfer escalates with the Sort number and decreases with the escalation of Smith number. The velocity and concentration escalate by the escalation, mean increasing of modified Grashof number GM and thermal Grashof number GR, and reverse means a reverse scenario is observed in the temperature field. So these are the conclusion I found, sir. Okay, thank you very much, sir, for given the opportunity. Anybody having doubts, please, sir.
Okay, thank you, Jinanand. Our next participant to present is Pulkit Kumar Nadian. Is available. Pulkit Kumar Nadian, unmute yourself.
Okay, sir. Am I audible, sir?
Okay, yes.
Okay, sir. Please share my PPT, sir.
Okay.
Sir, I have sent PPT also.
PPT also. What?
Yes, sir.
I think PPT is not available here.
PPT इन्होंने पहले भेजी होगी.
नहीं सर, साथ में भेजी थी इसके साथ.
इसी पे?
जी
इस पे
जी.
तो PDF आई हुई है.
There is only PDF.
अच्छा, मैंने मेल की थी सर.
हाँ, तो मैं मेल पे होगी ना.
हाँ, अगर है तो कोई नहीं सर, इससे कर दूंगा प्रेजेंट, कोई दिक्कत नहीं.
Okay, continue with this.
Okay, sir. Okay.
उसे डाउनलोड करने में टाइम लगेगा.
Okay, sir. Please, myself, Pulkit Kumar Nadian from HDPG College, Muzaffarnagar, a research scholar, and my paper's title is Thermal Instability of Dusty Coupled Stress Ferrometric Fluid in Presence of Rotation and Horizontal Magnetic Field Saturating in a Porous Medium. Next slide, sir. Next slide, sir. Mathematical formulation of the problem. Yes, sir. और थोड़ा नीचे, थोड़ा नीचे सर. Equation number, yes sir. Equation number 5 to 13. These are the governing equations of my system, where the fifth equation is the equation of conservation of momentum. Sixth equation is the equation of continuity. Seventh equation is the seventh and eighth equation are the Maxwell equation of electromagnetism. Fifth equation, ninth equation is the density equation of state. 10th and 11th equation are the equation of motion and continuity for the dust particles, and the 12th equation is the equation of heat conduction. Next, sir, basic state and perturbation equations. In undisturbed state, the fluid is at rest. The basic Michelin solution is given by equation 14. Also, equation 15 represents the perturbed flow where Q, U1, U2, U3, QD, LRS, H, X, HY, HZ, theta, delta rho, delta P, and delta M, respectively, perturbation in fluid velocity, dust particles velocity, magnetic field, temperature, density, pressure, and magnetization. Now, using the basic motionless solution representing by equation number 14 in governing equations for the system and eliminating them, we get these equations from equation number 16 to 23. Okay, sir. Now, sir, dispersion relation. The dispersion relation. Next heading, sir.
Okay, continue.
Yes, sir. Now, after applying some operations on Cartesian form of linearized equation, we go to the next step, that is the dispersion relation. Using normal move technique by decomposing the disturbances in the following form, which is represented by equation number 41, where kx, ky are the wave numbers in x and y directions, and under root kx square plus ky square equal to k is the resultant wave number of the disturbance, and n is the frequency of an arbitrary disturbance, which is a complex constant. Okay, now using the above relation, we get the equations in non-dimensional form from equation number 42 to equation number 46.
Okay.
Okay, now eliminating x, theta, k, and z among these non-dimensional equations, we get the final stability equation as equation number 47, where Rf is the Rayleigh number for ferromantic fluid, Ta is the modified Taylor number, Q is the Chandrasekhar number. Okay, now taking the case of two free boundaries, the appropriate boundary condition at z barabar 0 and z barabar 1 is as below, which is represented by equation number 48. Now the proper solution characterizing the lowest mode is W barabar W0 sin pi z, where W0 is a constant. Now using this relation W0 sin pi z in the final stability equation, we get the following equation represented by equation number 50. Now analytic discussion. Okay, sir.
Okay, conclude it.
Okay, sir. Okay. Analytical discussion, stationary convection.
आगे बढ़िए
जी सर जी. When stability sets in the marginal state, now to study the effect of dust particles, medium permeability, couple stress, rotation, magnetic field, and magnetization, we found the following derivatives, that is dr1 upon dv, dr1 upon dp, dr1 upon df1, upon dta1, dr1 upon dq1, and dr upon dm0, by which we can say that these parameters, some have stabilizing effect and some have destabilizing. I provide some graphs showing the destabilizing and stabilizing effect on the system.
This is the conclusion.
Ji sir, ji.
Okay.
These are the conclusions.
Okay, thank you.
Thank you.
Okay. Now, Dr. Rakesh, I have joined, and next is Mr. Sajal Sahi. Mr. Sajal Sahi is ready for his presentation. Mr. Sajal Sahi is ready or not?
Yes, sir. I'm ready.
Okay.
Sir,
Okay.
please allow me to share my screen.
Okay.
Yes,
Dr. Sundar Singh.
You want to allow yourself?
Yes, sir. Thank you very much.
Okay.
May I begin?
Yes, start. You may start.
Okay, so good morning to all members present here. I am Sajal Shahi. So I will be discussing analysis of a prey predator model with effect of primary and secondary toxicants on prey as well as predator species. So
okay,
that we have Then the abstract, we have written the literary review. We have assumed some stuff to formulate our model. We have found out the boundedness and dynamical behavior. We have also found out the local stability using the Ruth-Hurwitz criteria and the numerical simulations using MATLAB. We have also found out graphs to go with the numerical simulation. So let's begin. So in this paper, we have studied a model with prey and predator, who both are affected by the toxicants of the environment. The secondary toxicant is derived from the primary one and is also more toxic than the primary. We have also found out the bindedness of the system, and by which we have found that when there is pollution, the system is stable. Also, if the pollution increases, the population of predator and prey both decrease. So, as you know, we are confronted with many environmental problems like pollution, poison, and toxicants. These factors change our ecosystem in many drastic ways. These toxicants are released by many sources. Recently, Shukla and Dubey have proposed a model of two toxicants with unequal toxicity side by side. They assume that both the toxicants came from different sources, but we have assumed that the secondary toxicant has come from the primary and is more toxic than it. One of one of its examples could be sulfur oxide, as it turns into sulfuric acid, and we know that sulfuric acid is more toxic than sulfur oxide. So this makes this example more realistic and practical.
Right.
So here are a few assumptions we took to formulate our model. So we have taken that if the uptake rate of toxicants increase, then the growth of prey population lessens. So these are the differential equations formulated. The first equation shows about the susceptible prey. Here we can see that in the second equation if that if the carrying capacity increases, then the infected prey will also increase. And the third equation shows us about the predator.
Hmm.
we have uh, we have also found out the boundedness and dynamical behavior of the model using this theorem. Here we can see that m1 plus m2 plus n is less than equal to p naught plus delta k upon delta. This shows that it is bounded. Similarly, L1 plus S1 is less than equal to J upon rho 1, and L2 plus S2 is less than equal to theta kj upon rho 1 rho 2. So this proves that all of them are bounded. We have also found out the local stability using the Ruth-Hurwitz criteria and a characteristic equation. We can see these conditions uphold. For the numerical simulation, we have used MATLAB. We have found out the biological and physical parameters. So, as listed below, the table shown is very important. It shows the values of all the parameters for different values of theta. Here, we can see that when the values of theta increase, the values of these parameters will decrease. This shows that if the toxicity is more, the population is less. Here there are graphs which support the earlier observation. The results we find from the numerical simulation are that when the no primary toxicant was transformed, as the rate of transformation increases, we see that the population also see that whenever theta will increase, the population will decrease. Here we conclude all we have discussed today. It can
Hmm.
be concluded through a numerical simulation that
जी जी
if the
बोलिए.
pollution increases, the population will not be able to survive. So, for the survival of the population, the pollution should decrease. We have
Okay.
also shown that the boundedness and dynamical. Any questions?
आपने कुछ इसमें ग्राफ का जिक्र किया था, वो ग्राफ शो नहीं करेंगे क्या आपने?
सर करें?
अच्छा अच्छा, वो स्क्रीन, हाँ स्क्रीन पाए नहीं थे उस समय। ठीक है ठीक है ठीक है ठीक है ठीक है, ओके थैंक यू। यस, एनी क्वेश्चन? किसी से है कोई क्वेश्चन? नाउ आवर नेक्स्ट पार्टिसिपेंट इज स्मृति सक्सेना। स्मृति सक्सेना, कैन यू हियर मी?
Hello. Smriti Saxena is available? I think she is not available. Our next participant is to present Dr. Kondla Rao Kanapati is available. Dr. Kondla Rao, can you hear me?
Yeah, sir.
Sir.
Good afternoon, sir. This is Dr. Kondla Rao, sir.
Sir, I will present my paper in place of Smriti.
Can you give the permission to share my screen?
एक मिनट डॉक्टर कोंडला।
Sundar sir, there is.
Sir, myself, Dr. Anil Kumar Tevatia, and Dr. Anil Kumar permitted me to present paper in place of Smriti Saxena. She is not present.
अच्छा।
Okay, sir. You may
go. Okay.
Dr. Kondla, एक मिनट sir. Dr. Kondla, wait. After this, we may allow to you.
Okay, sir. Thank you.
It's time for the Dr. Smriti.
Okay, sir. Okay, sir. Thank you. No problem.
Yes.
Okay. Good afternoon to one and all. And myself, Dr. Anil Kumar Tevatia, working as principal in one of the teacher training institute in Delhi, namely DIVE, in Dilshad Garden. And first of all, thanks to organizers to provide an opportunity to present my paper. And my topic is advancement in the teaching and learning of mathematics. I don't want to share screen because I have no graph and equations in my paper.
Okay, I share, sir. I share.
You can proceed,
No need, sir.
Okay.
No need.
The question about the teaching of mathematics or how mathematics is taught always persists in the minds of all the educators. To answer this question, one has to understand about nature of mathematics. What is mathematics? Mathematics is considered a science of all sciences and art of all arts. It is a language of logic and root of reasoning.
किसी की साइड की आवाज आ रही है।
Sundar sir, better to share screen.
Okay.
Mathematics lies in the epicenter of the universe. Learning mathematics is vital in learning of any discipline. It is essential for all individuals. The result of various standardized tests and achievement survey reveal that mathematics learning is deteriorate in the recent past. Math phobia is not an unknown term these days. Almost all the children at elementary level or secondary level begin to develop a thought that mathematics is a difficult subject and out of their reach. However, the reason behind this are beyond the scope of the present research paper. Mathematization is the key of teaching learning process. Since independence, educators are working to improve mathematics learning. The revision in curriculum and textbook are revolving from time to time. These revisions have failed to realize the aim and objectives of mathematics learning. Our traditional assumption and belief are still in power and dominate the whole teaching process of mathematics, things that have changed.
Just 1 minute, sir. Just 1 minute. Sir, allow me to share your...
Okay, you can, sir. You can.
Yes.
Until recently, rote memorization was considered as one of the effective methods of learning mathematics. Tables, fractions, equations, formulas were considered as something which cannot be questioned. And hence, a student must learn it by heart without any alteration, any question. Everything was taught on a blackboard as it was supposed. Next, sir. Next slide. Next slide, sir. Yes, stop. Please stop. It was supposed to be the only means of transmission knowledge, the use of teaching and learning material used to be ignored, and student fear from mathematics. It was felt that these things could hinder the understanding, and the student engagement in their learning of mathematics was minimal. Today, if we want to describe the change in the learning of mathematics in schools in one word, we have to say extraordinary. Now, in primary and secondary or senior secondary schools, children are involved in their learning. The teacher is no longer a preacher, but a guide, facilitator, and motivator. The traditional math approach believe in providing tool to student and then asking them to practice using these tools in the applied way. The focus here is on the procedural understanding rather than cramming or rote memorization. It is more focused on concept clarity and understanding. In the new approach, we spend less time in the classroom discussing the procedure and algorithm, but spend more time finding out the novel problems and situations in which we can apply logic and develop scientific and mathematical attitude among students. Activity-based method of teaching mathematics are producing better result. Use of activities in mathematics has a positive impact on the performance of learner. Students take more interest in the lesson if activities are mathematics because activity-based teaching or learning stimulates a high degree of interest in the learner and may make the message very clear. Why was this change needed? In the research, it was claimed that a student were able to learn mathematics by rote memorization of particular algorithm. Next slide, sir. They lack number sense and intuitive understanding how number are related to each other and how number are compromise of other numbers. In simple word, students were able to perform basic operations in mathematics, but they find failure in dealing with algebra, trigonometry, and calculus or more advanced concept. The reason behind this is the no understanding of how to manipulate equations before solving them. Students are frustrated and give up very soon mathematics because there was no simple method or formula anymore. And if I want to discuss about education psychology advancement and its relation with mathematics, the researcher around the world studied the professional mathematicians for solving and analyzing mathematical problems. So new methods are working on the development of the understanding in the minds rather than memorizing the short trick of solving the questions, equations, or a particular problem. Math is math. Yes, math is math. There was a joke trending on social media and it was directly related to mathematical advancement. That is not the way you are supposed to do it, that a child says when his dad solves a math problem.
Please conclude, sir.
Yes, sir, yes. Father says, I don't know this way. Why would they change math? Math is math and math is math. Answer is everything. But I want to conclude my paper. Learning mathematics is vital in learning of any discipline. It is essential for all individuals. The result of mathematics learning will be more fruitful if children and students with engage mathematics and mathematics teacher. The teacher is no longer a only work as preacher. In the new approach, we spend less time in classroom, finally, which we can apply logic and our already developed concept so that new ways of solving the problem can be learned quickly. That's it from my side. Thank you very much. If any answer, any question you have, so I will
thank you.
क्वेश्चन कोई नहीं है अनिल जी, आपने बहुत अच्छी जानकारी दी, धन्यवाद आपका इसके लिए. थैंक यू वेरी मच.
Thank you, sir.
Our next contest, our next participant is Dr. Kondala Rao. Dr. Rao, are you ready? Dr. Rao, are you ready for? Okay.
Yes, sir. Thank you. Thank you. Good afternoon, sir.
Please
Okay.
proceed. Good afternoon.
So can you give the permission to share my PPT?
Yes. Sure.
Okay, sir. So good afternoon, everyone. Sorry, visible my PPT, sir?
Yes, yes, yes.
Okay,
Yes,
sir.
Yes.
Good afternoon, sir. This is Dr. Kondarao Kanapati from Vidyajyoti Institute of Technology, Hyderabad. So today I'm going to discuss the model is a mathematical study of three species emmensolism model with the harvesting. The abstract of this model is the present in this model we discussed that harvesting, we apply the harvesting effect of three species synecological model in which first species is emensal on the second species and second species is emensal on the third species. Third one is emensal on the first species. That is emmensolism on the chain process for the three species model. So in this here, first species and second species are harvested at a rate proportional to their population sizes. And we discussed the coexisting state. There is a local stability on the coexisting state, and the local stability is discussed. Solutions of linear equations are carried out. Further, with the help of suitable Lyapunov function, we constructed the suitable Lyapunov function and we verified the global stability of the model in support of analytical results. Numerical simulation were carried out using the MATLAB.
Okay.
So keywords of this model is emmensolism, harvesting in the interior equilibrium point, Lyapunov function, Hurrell-Hurwitz criteria. And basically what is the emmensolism is the relationship between the two organisms, whether one is harming another one without getting any benefit or loss. Second one is harmed, second one is spoiled because of the first one is harming, and without gaining any benefit or loss, the first one is harming the second one. So so many examples we have in emmensolism in the real world. So the first example I took that cattle styles and the forest growth are some like in humans are being giving the pollution, so harming that trees or plants or birds because of the pollution without getting any benefit or loss. So that the basic equations of this model is given by that equation 2.1. In this, dn1 by dt equal to 1 minus k1 into a1 n1 minus alpha 1 n1 square minus alpha 1 3 n1 into here n1 into n3 as the population of the first, second, third species. A1 is the growth rate of the first species. Alpha 1 1 and alpha 1 1 alpha to A1, A2, A3 are the growth rate of the first, second, third species. Alpha 1 1, alpha 2 2, alpha 3 3, alpha 3 3 are the rate of decay by the internal computation of internal computation itself. And alpha 1 3 is the rate of decay of n1 by the effect of n3, and alpha 21 is the rate of decay by the computation of n1, alpha 32 also similarly. So these are the we have basic equation given by 2.1. The notations are given here. K1, K2 is the harvesting rate of first and second species.
Okay.
The equilibrium points. So we studied the system of actually under a system you have 8 equilibrium points, but we concentrate on the only 8th equilibrium point that we call coexisting state or interior equilibrium point we call as. Here 3.1, after solving that we got the n1 bar, n2 bar, n3 bar, we got the equilibrium points. The 3.1 would exist only when the 3.2 satisfying this condition satisfied only this state that n1, n2, n3 should be positive. Then if 3.2 exists satisfying, then only 3.1 exists. That n1, n2, n3 exists. But now stability of the coexisting state. To examine the stability of the coexisting state, we assume the small perturbation u1, u2, u3, where n1 equal to n1 bar plus u1, n2 equal to n2 bar plus u3, u2, n3 equal to n3 bar plus u3. After
मैं क्या बताऊं, मैं तो खाली 11 मिनट के में हो ही पाता है, किसी का 10 मिनट ज्यादा हो सकता है.
Sir,
next ले लीजिए next.
Okay, sir. So after linearization, we get 4.2, so that we vary the Jacobian matrix and use the perturbation. So here, after solving this equation, after solving that characteristic equation, we got the 4.6 linear equations of 4.6, and the characteristic equation is 4.7. Here, after verifying by the Hurrell-Hurwitz criteria, P1, P3 greater than 0, and P1, P2 minus P3 greater than 0, then the interior equilibrium point is locally stable, asymptotically stable. The solutions of the perturbation equations by using the Laplace transformations, inverse Laplace transformations, we've identified that solutions. So that
इक्वेशन को चलाते रहिए आप, हम देखते रह रहे हैं, हम देख रहे हैं, ठीक है ना, आप बोलते रहिए.
Okay, sir. So that these are the numerical examples for the this local stability
This
for
is
the
the
different values without
ठीक है.
harvesting and with harvesting.
Right,
And
right, right.
now I'm going to consider on global stability. We
Global.
consider the small
ठीक है.
Bradabuston equation 5.1. After verifying
Okay.
that after solving this process, we got dV by dt is less than 0. By using that Rautharovich criteria, this system is globally asymptotically stable.
Okay.
So when we changed that parameter, that interacting coefficients between that first and second species, second and third species will get without harvesting and with harvesting. There is the difference
These
between
are
that.
Okay, okay,
Difference
okay.
between that population increase, population size, so that this equilibrium point, that N1 into N3. So we verified the three different values.
Right, 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 right.
And the conclusion is from the numerical simulation, we observed that when we decrease the interacting coefficients between the species of first kind and the species of third kind, then the species of second kind and the species of first kind, the species of first and second kind was strengthened, and the species of third kind was weakened.
Okay, okay, okay. Thank you
Similarly,
very
we
much.
discuss it.
Thank you,
Okay,
dear.
sir.
Thank
So,
you very much. Okay.
so these are the references.
Hello.
Thank you, sir. Thank you, sir. Is there any questions, sir?
Hello.
Okay, okay.
Okay, sir.
If,
Thank you.
Hello.
Hello, Dr. Rakesh.
Yeah. AY Sheikh is there? Yes. AY Sheikh is there? Hello.
No, sir. Next participant is Rajesh Ramchandra Rao.
नहीं, AY Sheikh को आवाज लगाओ पहले.
No. He is not
Four
available.
number. Four number.
Sundar Singh, physics.
Yes.
एक मिनट.
Participants for physics. Have they started?
No, sir. I think we do not have time because we close it at 2:30. So
okay.
So I think today's participant we will take on Thursday.
Okay. You give some other time to them and inform me also so that.
Day after tomorrow, I think 30.
Okay. No problem. No problem. As per your convenience, you can decide the time and date.
Yes. So as we do not have time, at 2:30 we will must close. So मैं सोचता हूँ कि जो आज के पार्टिसिपेंट्स हैं, जो भी फिजिक्स के हैं, उनको हम 30 तारीख को बोलने का मौका देंगे. और इस उसमें हम दो प्लेटफॉर्म चलाएंगे, 30 को भी, और कल भी हम 2 प्लेटफॉर्म करेंगे. अब एक गूगल पे कर देंगे और एक यहाँ पर कर देंगे, जिससे कि ये जो क्योंकि ठीक, जिससे कि हम जो है पूरा वो करवा पाए. ठीक है.
ओके.
तो आज जो भी पार्टिसिपेंट फिजिक्स के थे उनसे मैं माफी मांगूंगा एक तरह से. सॉरी, वी कैन नॉट गिव यू टाइम टुडे, एंड एट लास्ट आई विल वांट्स टू गिव ए वोट ऑफ थैंक्स.
एक बात मैं कहना चाहूंगा राकेश जी. हाँ, ये पार्टिसिपेंट से मैं एक गुजारिश है मेरी कि वो जो अपना प्रेजेंटेशन देते हैं ना, जैसे जितने टाइम उनको अलॉट किया जाए वो उसमें कोशिश करें खत्म करने की. जैसे अब ये 5 मिनट में खत्म नहीं कर पा रहे हैं. अब जैसे इक्वेशंस है, ये इक्वेशंस वो पढ़ के बोलते हैं, हालांकि इक्वेशन स्क्रीन पे आ जाती है, हम उन्हें पढ़ लेते हैं स्क्रीन पे. तो वो इस तरह से भी कह सकते हैं कि सर ये मैंने 4.6 इक्वेशंस में डिस्कस किया है, और इसके बाद नेक्स्ट मैंने 4.7 में डिस्कस किया है, ये चीज मैंने 4.8 में करी है. इक्वेशन को पूरा पढ़ने की जरूरत नहीं है वहां पर, वो तो हम स्क्रीन पे देख ही पा रहे हैं पूरी. है ना. तो थोड़ा सा अपने जो प्रेजेंटेशन है उसे थोड़ा सा और शॉर्ट करके वो उसको प्रेजेंट करें तो अच्छा रहेगा. ये मैं फिजिक्स वालों के लिए भी कहना चाहूंगा कि फिजिक्स वाले भी इस तरह से तैयार करें कि वो थोड़ा सा इक्वेशन को ना पढ़ते हुए बल्कि उसे एक्सप्लेन करें. ठीक है, थ्योरेटिकल. ओके, थैंक यू.
सो थैंक्स टू द participants, and now I will give vote of thanks. A warm and graceful good afternoon to our most valued honorable chief guest, Dr. Prakash Chauhan, Director IRRS, Dehradun, keynote speaker Atul Nagar, from Hope University UK, Dr. Amit Bharadwaj, Pattern, Joint Secretary Higher Education Lucknow, and Dr. Rajesh Prakash, Regional Higher Education Officer, Rajiv Kotiwal, President, Hindu College, Dr. B.V. Singh, Principal, Hindu College, and research scholars and students gathered here. It is my privilege purpose a vote of thanks speech and acknowledge the contribution who worked really hard to make this celebration our conference. And on behalf of my college, I extend really hearty both thanks to all the participants and our last my gratitude to all the speakers for gracing the occasion and sharing their opinions today. In the last, I extend my thanks to our team members of organizing committee and the audience. Without their support, we could not organize this conference. So once again, thanks to all the participants. Thanks. Okay. So today we close this session, and next tomorrow we will meet at 11 o'clock. So you must join at 10:45 so that we can run at time. And tomorrow for our participants, presentators, we will have two presenting platforms. So one on Zoom and second on Google Meet. So we will share you the Google Meet platform in the evening. Okay, thank you.
Take care.
So, okay.
Okay, thank you, Rakesh ji.
Okay, thank you, sir.
Allow me, sir, to end the.
Yes,
Yes.
Thank you, sir. Thank you very much, all of you, and very good afternoon.
Okay, bye.